AIET. Now this author has tried to address the problem of detection of disease in pomegranate. He has used a minimum distance classifier for classification purpose. So color, morphology and texture features were used. And this author has also taken the data set, his own data set. The Swati and the next author, she has detected the disease in general. So she has used support vector mission and near nearest neighbor decision tree and convolution neural network. She has used different algorithms and she found that using CNN was the best approach of detecting the disease. The next author here, he has addressed the disease in cucumber plant. So he has used artificial neural network. The factors considered here are texture. So the images were acquired from the digital cameras. Texture feature was considered. The next author here, he has detected the leaf spot disease in soya plant. Here he has used OTSU method. It is nothing but it's a global thresholding method of separating the background image from the foreground image. And he has also used for color segmentation, he has used a hue saturation intensity color system. So disease spot regions were segmented by using Sopel operator, which is a region-based segmentation operator. The leaf images were taken on white background such that the optical axis of the digital camera is perpendicular to the leaf plane to shoot images. So this is also the own data which the author has used. He has not considered any of the real-time images. The next author, Mohammad Rami, he has tried to address the problem related to tomato disease detection. He has used convolution neural network and occlusion techniques. Occlusion is nothing but when two objects merge. The object which we are trying to find the disease area of interest, it will be hidden by something else. So this also he has addressed, but he has taken only when the object of interest is merged or coincided with two or more objects. He has not considered multiple objects. So here he has considered spots, color and light. He has taken the data, real-time data, he has taken the data set from an open access repository. So I have considered the diseases in different plants like soybean, pomegranate, tomato and cucumber and areca nut. So the key issues here is the quality of images taken is very important for the accuracy and efficiency. If the background images have to be removed, light conditions only in particular controlled environments when the images are taken, it is showing the accuracy. Say for example, the image is taken in dark, so it is not showing the accuracy. Large data set need to be gathered, this is one of the issue. So noises have to be removed from the images and we have to address the issue of occlusion, that is merging of two or more objects. Data sets have to be trained and prepared. So classification of healthy and unhealthy leaf images have to be done, this is one of the key issues. So different parameters are considered and authors here they have considered only few diseases, not all the diseases. So it has to be, research has to be carried out in those areas. So conclusion here is, in this paper there is a brief glimpse of various image processing techniques such as pre-processing, noise removal, feature extraction, clustering, segmentation is presented. This paper just focuses on the approaches that have been used to identify the heterogeneous various kinds of diseases affecting the plant leaves so as to reduce the burden on the farmers.
Okay, I think we can take some. Anyone is having some question? Anyone has question from the audience? No question. For students, you should your final presentation will be like this, right? You should remember how they are organizing the content, how they are presenting the literature and everything. You should try to understand from this. Okay. So there is one, two observations. One is that please go to your title. Yeah, your titles, your work and your title, they don't match exactly actually. Tell me what is missing in that one.
I think the survey and detection of diseases in plants using using machine learning algorithms.
Actually, it is not that one. See, whatever the work you have summarized is based on leaf. See, it is not, your work is not a general work. That is used to detect the diseases in plants. So the plant disease may be due to root problem also,
Yeah.
due to stem problem also, but you have not considered those problems.
One author, the first author, have considered.
No. I am telling. See, when you are presenting the work, that should be properly summarized. So I hope that your work somewhere you should use leaf-based this disease detection.
Yeah.
That is missing in the title, right? You agree or not?
Yes, sir. Yes, sir.
So because if you tell that only diseases, then it can be from the stem, it can be due to the environment, it can be due to the soil, it can be due to the manure, or maybe the land which is the problem, right? So there are many things. So that is not considered. That's why you should fix number one. Number two is that somewhere in your slides you said that you have considered papers from 2018 onwards.
2008.
2008 onwards. So why is that a hard deadline? It is not. Being a researcher, you should not say like that. So at least see, you can say that. Don't mention that, but at least you can take, because there might be some representative work before 2008 also that may be useful for you. So seeing that I have taken from this one doesn't generalize, right? So you should take care of that one. So other than that, I think see, main thing you showed some list of problems. So better is that list of problems you already showed the issues, right? That one. Can you try to give some solutions for that one, or can you try to categorize? Like for example, here there is no systematic categorization. It's only list. Author name is there, only paper title is there, some what this is. But where is the actual? What can I say is that observation. Like observation means classifying based on some KNN. So or classifying based on some diseases like tomato, apple. They are all small category of leaf. If you take banana, then it is a big leaf. So the purpose of doing literature survey is to come out with some new knowledge. You understand what is new knowledge? Generate some tables. Because why someone should read your paper, survey paper? If there is no new knowledge, why you should read it? Why you can't go through the papers? So that thought should be there when you are writing any survey paper. Is it fine? Okay. Good. The presentation was good, right? So this was small. Sir, you have any observations?
A very good presentation. As Sir rightly mentioned, gap in the literature that needs to be done. Gap. That is one specific column in any presentation. One specific slide has to be included. Actually, what you have done is correct. All these informations about data set accuracy. One slide missing is, as Sir has rightly mentioned, the gap in the literature. And then you can tell that what is missing in that existing work. Then you carry forward it to your research aspect. Then your paper will be useful for all the research people. Otherwise, it is good. It is a literature work now. What you have done extensively, what you are going to do. One more thing that I would like is to add is that what methodology you can implement to find the diseases. Probable methodologies. Because you have studied literature, you have come up with, you have mentioned the computer vision, then machine learning, convolutional neural. You can discuss with among all these techniques, and you can conclude it among this kind of methodology or the flow of model, we can achieve this the result. This is one tentative approach, not a concrete approach. You cannot say any concrete approach because it gives others to analyze. Then it will be quite interesting paper when you publish it with such a method. That's all.
All the best. All the best.
Thank you, sir.
Thank you, ma'am. Now I request paper ID 25 with the title An Approach to Conserve Wildlife Habitat by Predicting Forest Fire Using Machine Learning Techniques to present the topic. And Until then, I ask paper ID 25 to be ready.
In this there are only 2 authors, but there are 4 authors. Huh? अच्छा, वो दिए हम ही
Yeah, good afternoon and all who are present here. Myself, Professor Santosh, working assistant professor, Department of Information Science, NMM Institute of Technology. Along with me, my colleagues, Professor Balaji, Deepa Kumari, and we had collaborated with one of the staff from Reva University, and we have collaboratively worked on a specific problem. The title, An Approach to Conserve Wildlife Habitat by Predicting Forest Fire Using Machine Learning Techniques. So we will be brushing through a few of these contents shortly. So we will be speaking much on the methodology. We will see what are the machine learning techniques which are helping us in trying to find out the forest fire and trying to safeguard our wildlife. So as we know, even Karnataka is also a very environmental friendly state where we have most of the state covered with the forest area. We can quote few forests maybe like Pandipura and other states. So here we have heard in the time of summer seasons that forest fire picks up, and even for major developed countries, maybe like US and also certain African continents, wherein the technology has improved to a greater extent, but once this forest fire catches up, so this becomes impossible after once it has picked up. Initially, if it is found out, then it will be in the hands of the fire safety people, but then once it has gone ahead of the restriction level, then it creates lots of chaos. It also affects in terms of global warming and water scarcity, and majorly some endangered species in deep forests. So they will reach to a level of extinction. So this is where we mainly are concentrating much. So even in India, if you take in the previous month of March, because of global warming, with the additive of forest fire and these stuff. So what happened was we experienced the third warmest temperature in last 100 years. So we basically try to incorporate certain machine learning models along with certain tools in order to try and predict the spread of these fires in certain areas. So some extensive literature survey worked on considering different researchers who have worked on specific algorithms, maybe certain machine learning algorithms which were in some way deep learning techniques. So and certain data mining techniques wherein the data in terms of FFCM, that is your fast fuel, moisture code, or it might be the drop code, this type of prediction data, and certain ANS and logical regressions were applied to few of the contents of the data set. So based on that, we try to analyze what type of work has been done in terms of the previous survey. So based on that, we try to formulate an architecture So wherein we try to collect an existing data from any of the wildlife conserving data unions where the data set is acquired in terms of FFCM. As I was mentioning, the fast fuel moisture code, then drag code, then the moisture content, ISI, that is the content level where how the fire spreads. So based on this, so we try to allocate this to the machine learning algorithms, and based on that the pre-processed data which when they are applied to the machine learning algorithms, so we try to evaluate the efficiencies based on accuracy, lean and kappa, and based on that we can predict to a certain extent. So if there is a chance of a forest fire, and how can we try and tackle on to that. So few of the methods like when we try with the SVM algorithm, what outcome we got was that we can draw a specific line between the fire and non-burning forest area, so which helps us in trying to point out the hot specific area onto which we can try and concentrate more when compared to that of scattered areas. And based on the decisions, we apply our core entities to decision tree and try to classify based on various parameters like I was mentioning in the data set. And based on that, the classification and regressions, so we try to decide in the later part how actually we can handle it. So some of the results, once we have formulated the entities, like in the first result you can see the density of the forest area with the attributes what we have considered. So based on this, it gives a hint on how we can try to act on the intensity of the fire in a specific part of the forest, and the exact location of the burnt area where we need to majorly concentrate related to the fire, and how to extinct that and these stuff. So deep insight into how we can try and manage the forest fire, and in terms of that how we can try and reduce the global warming, and also maybe we can work out in trying to preserve certain endangered species. So major meteorological variables like temperature, relative humidity and wind spread were tried and taken into consideration, and we worked on that. So these are a few of the references that we considered, and thank you very much.
Reference. Year of publications, specify one. You have not mentioned the year of one or two.
So,
2009
2009.
in literature,
Yeah.
you have not mentioned that.
I didn't go discussing much on the literature.
Yeah, go to the proposed model. Proposed model. So here you are not proposing any approach as such, but you are only
We are just working on different machine learning algorithms with the
just
data.
experimental.
Yeah, experimental.
But the experiment, see, that's okay, but the experimental result is not showing that one. Can you go to the previous slide, next slide? It is the next slide, yes, architecture method results. So what are these results? Can you give the interpretation of the results?
So we have considered in the data set around 8 entities like FFCM, that is the fast fuel moisture code, that is the content of the forest currently, whether more number of.
But that should be experimented with all the methods like random forest, SVM, but that result is not sharing. Which one is better? Which one is
Yeah,
better?
accuracy, index and kappa that we have done in the paper, but
Oh, you are not
didn't
mentioned here.
mention.
Okay, so that's good. If you have done that one,
We have done
in
it.
the paper, then it's
But it mentioned.
okay. But that should be set clearly. Other than that, fine. I think if you have any queries from the audience, yeah, you can just ask. Any question? There is some question, please.
Sir, in the literature survey, you have mentioned that some work has been already done using artificial neural network, and your paper is based on machine learning.
Yeah.
But as per my knowledge, we go for artificial networks when we can't achieve, like when the data set is large, then we go for artificial neural networks. But you are going back from artificial neural network to machine learning. How your work is superior to?
Yeah, I do agree with the analysis what you made shortly. Actually, major papers which they are working on, so they are out of the dataset entities what we have considered 10 entities. So majorly they are concentrating on the moisture code. That is, for example, if we consider African continents where the drought level is too high and the intensity of fire there would be much more when compared to other countries. Maybe if you take countries like US where they experience winter very extensively, and the type of bed of the forest is different. So there what we tried was, we tried to combine the machine learning techniques with that of the ensemble deep learning techniques, and we try to predict based on increasing the number of entities.
Thank you.
Okay, good presentation. Okay.
Thank you.
All the best.
Thank you, audience.
Okay.
Thank you, sir. Now I request paper ID 31 with the title Aquaculture Monitoring System to present the topic. Till then, I request paper ID 35 to be ready.
So, I am Pushkar. I am currently a final year student in my MIJAR from my CSE department. So, paper is named as Aquaculture Monitoring System, Descriptive Model. So, this paper tries to address a problem in aquaculture that we think can be solved by using machine learning and deep learning techniques. So, we'll first go to the motivation for this paper, the objectives of it, then into the methodology and the results. So currently fish is one of the largest traded commodities in the world. It is valued, the fishing industry is valued at around $3 billion globally. And because of this demand, there are certain consequences. One of the main one is overfishing. Basically, fish stocks are exploited so that they cannot be replenished, and this has led to loss of biodiversity. So aquaculture provides a sustainable alternative to this. We grow fish in cages and breed them so that they can be used for our needs without actually exploiting natural environment. But there are certain challenges in this. Which deter farmers, fishermen from actually adopting aquaculture. So one of the main is that managing and monitoring is extremely expensive, but constant monitoring is extremely necessary in this case because there are certain values, rather certain environments within which that the water should be. Their fish are incredibly sensitive to their environment, and if the values change, even in minute changes, the whole yield can die off in hours, and this can lead to economic loss. This is a major deterrent. So the objective of this study is to analyze water quality parameters, see which parameters affect the fish and how they interact with each other, then to predict them so that if we can predict that water quality is going to deteriorate, we can ensure that it doesn't happen by taking certain measures. We also propose a non-contact method for measuring the length of the fish. So measuring the length of the fish is an excellent indicator of its health. Currently, the traditional methods involve taking the fish out of the water, measuring it, and put it back. But this is also harmful to the fish. Also, to provide easy access to this data, we provide a web-based application. So this is the overview of the entire system. We'll get to the working of this data. So the data for this study was collected over 4 months from the backwaters of River Varna, and from these are 9 parameters that we collected. So from these 9 parameters, through data schedule and through correlation maps, we are able to ensure that water temperature, DO, pH, as well as salinity were the only important features. So yeah, basically that only these 4 parameters, that are water temperature, DO percentage, pH and salinity, are the important features. So this is the correlation map that proves this, and these graphs further show the variation of this parameter relation between these parameters. So the first one is mainly how DO varies with water temperature and so on. Now, so after we have identified the necessary features, we had some missing values that we needed to take care of. Then we used MIJAR normalization because the ranges were very different. The pH was values from between 0 to 14, and the values of water temperature were in the 30s. So then after that, the data was split into testing and training data sets. Basically, it was 70-30 split, and we used an LSTM model to predict the temperatures, predict the future values. So beta size was 4. That is, the current the future values were predicted based on the previous 4 values of all the 4 parameters. And after this, we used rule-based anomaly detector to check for anomalies in the predicted values. So after that, to determine the growth rate of fish, we initially collected video footage using shared camera setup, converted it to frames, and we detected the fish in the footage, estimated that, and the estimated the length of the fish. So to the state camera setup, we used 2 cameras with focal length of 2 mm and a field of vision of 70 degrees. Also, they were kept 8 centimeters apart. This was the baseline, and the camera had a resolution of 1920 1080 pixels, and we shot at a frame rate of 30 fps. So initially we had to cut and resize the frames into 1280 plus 936, because we used a model that was based on the YOLO algorithm for detection of fish, and this requires that the dimension of the frame be in multiples of 32 for detection. Then when we annotated the fish, by annotating, it has to be taken care that the fish annotated are parallel to the optical axis of the camera, so that when the length estimation is done, it provides a very good estimate. So a fish that is, say, in position of A, that is not parallel, it will give a wrong estimate. It will actually decrease the actual size of the fish. So this was the input. So input to the YOLO frame was simply a frame, and the output was we have a bounding box around the fish that it detected. After once this bounding box was detected, we found the centroid of the bounding box. So centroid of the bounding box. Then we used these formulas to calculate the depth at which the fish was from the camera. So baseline was set by us, that was 8 centimeters, and focal length in pixels was calculated using the formula. Now, to find disparity, we found the length of the distance of the centroid of the fish in both the cameras, the left and right cameras, from their respective left rims. The difference in this gives us the disparity. So from that, we were able to calculate the depth. So after that, we can calculate the estimate the size of the fish by using these formulas. Basically, we need the distance to the object, that is the fish, from the depth estimation that we did, and focal length was known from the metadata. To calculate the object size in the image in millimeters, we used the below formula, that is the sensor size and sensor pixels were we found them experimentally, and object size is basically the size of the bounding box in the frame. So these are the results. This was the loss curve that we had obtained for the LHD model, and this loss curve indicates that the model doesn't overfit. These are the results. We had an accuracy of 89% and MSE value of 0.30 for the predicted values. So these were the results of the estimation of the fish and size estimation and depth estimation. Basically, the first image indicates with what confidence the model says that it is a fish, and the second is its estimated size. So results of this were slightly skewed.
So in the previous slide, so is the camera fixed or camera is moving?
No, the camera is fixed.
Camera is fixed.
Yeah,
So that's why you get the distance. Otherwise, it will be a problem.
Yeah,
Right?
right.
Fine. Okay. And what about in case of like so this is a clean water, but if you take in our place, so it's
Murky water, yeah.
murky water, and as we go on in the depth,
Yeah.
so the water, the visibility, the light becomes.
That will simply decrease the range of the camera. So it has to be near, fish have to be near. Otherwise,
Yeah.
there is nothing you can do that can be done. Basically, you can try to enhance the light. That's all.
So I just wanted to ask whether is there any related work, because you have not shown any related work.
Yeah, there are related works, but they use other methods, not as simple as this.
No, I can understand. This is purely you have done based on the research, whatever you are doing. I understand that. But I'm asking that in this direction, whether is there any work, because I know that Fisheries College in Bangalore,
Yeah.
they also do a lot of work in this.
Yeah.
There is a Fisheries College, you know, this one near that Compel. After Compel you go. So they also do a lot of analysis with respect to. So you should see that in the internet if it's available.
Yeah. So actually, during this, we found that literature survey, but not in India, but in other countries,
Yeah.
it dates back to 1900s.
So you compare that one, right? Comparative study with respect to those papers. If they are related, that's
Okay. In this case, we will compare it to one of the recent papers that give good accuracy, but they use a different model. But the older ones we have currently.
I'm not asking about the model, I'm asking about the problem and the solution. You should compare whatever the answer you are getting, that should be compared with the any proposed work which is there. It may be any model, it may be machine learning, a simple feature, but you should compare the performance.
Okay.
Performance comparison is general, whatever you may use it, right? So you cannot say that I am using deep learning, so I will not use conventional models. No, not like that. Okay, fine. Good work, right? It's good work. So that's all done. Any other slide? Yeah.
So there was some errors in this, mainly because that even though we try to annotate the fish in the proper position, it still detects fish that are not entirely like in the proper orientation that we need. So this leads to decrease in the size of the fish. Also, matching the bounding boxes need to be matched, but the model it detects in random order, so we can't do this.
There will be definitely.
Yes. So the initially we found that the estimated sizes had an error of 1.5 centimeters.
So fish will not come and give the pose that you take my selfie.
Yeah.
Right? So, okay.
Just one. So the whole system works in such a way that whenever a new data point is, whenever a new reading is detected, it sends it to the server. The server cleans it and shows it in a database. And new process is one that retrieves previous data from the database, whichever is necessary, and predicts it. After predicting, it is denormalized, and if the predicted values are not in these specific ranges, they are flagged as anomalies. And this is the interface that is used to show. Also, it provides what action you can take based on the anomalies. It tells you what action you can take to prevent this. And so it's a prescriptive model. That's it.
Thank you, sir. Now I request paper ID 35 with the title Sign Language Recognition Using Non-Manual Markers, Facial Expressions with Symbolic Representation to present the topic.
University of Mysore under the guidance of Professor H.S. Nagendrasamy. Our paper is by the title of Sign Language Recognition using Non-Manual Markers, Facial Expressions, with Symbolic Representation. So, sign language being the medium of communication for the hearing impaired has definitely had, its own drawbacks as well, because we can't communicate with the hearing impaired. So hence the gap, and hence the birth of sign language recognition systems. In our case, our sign language recognition system has the following block diagram. So it includes the sign acquisition. You have pre-processing stages where you do rescaling. There's like cropping and segmentation, and the feature extraction region. Then we do it in number of stages. The feature extraction is done in stages, and finally the validation and recognition. So looking back into the related work, it was observed that many of the literature review have been focusing on either static-based sign language signs, or there have been like a finger level spelling, or like word level sign recognition. Some of them use multiple like video cameras, some of them use like gloves in order to do the recognition. But it was also observed that very few work has been done in the relation to sign language at the sentence level. Also, a very less attempt has been made in the direction of non-manual markers, which I shall cover and I shall explain what it is exactly. So, hence the motivation, and of course with every motivation and problem statement there are its own challenges. One of them being like the inter and intraperson variations when it comes to signing. So, given an input video as such, we are looking forward to extract the segmented region. So our region of interest being the hands and the face. Of course, what you see over here is a large database that we had created for the sign language. And this is done by taking an input video. We just break it down into various frames, each and every frame starting from frame 1 until the end of the frame. We pass it through the segmentation content, which is using the hue, saturation, thresholding, which is closest to the skin texture, and then we extract that region, running few morphological operations, and we got ourselves a masking of that particular frame. Now, for the part of feature extraction, we are using a modified version of locate scanning, optical flow. Again, everything that we see over here was done in our previous papers as a contribution. And these are a number of stages in order to extract those set of features that represent each and every video. So I'm not going to go through each and everything, but here is a pictorial representation of what happens with respect to one of the frames. As you can see over here, there is, okay. Yeah, you see this flush over here, it represents the direction and magnitude of that particular blob. And over here there is a small dot, so there isn't much of magnitude and direction. That is what is being done over here. These are all done in our previous papers. It's a cluster-based and chunk-based keyframe extraction and representation. And this was done in order to resolve the problem with respect to, let's say, here is one class. Do you have a system is one class? Now, one sample could have around 120 frames. The other sample could have like around 360, 200 frames, or even 75 frames. That depends on the frame rate of the camera. But in order to kind of normalize the whole thing, we are extracting a specific number, let's say 10 keyframes in order to represent. And this is done using the chunk-based and cluster-based method. All right, here is just an example of the output of the two different methods. Then we use the features, we apply the symbolic representation method in order to create an interval base of feature representation for each and every class. And coming to the main
topic, which is non-manual markers, which are an additional set of actions and behavior added up with the hand gestures and sign language in order to create a specific meaning to the sign. I can give you an example. For example, if I say this means shirt. If I have a facial expression, it means show off. You see, it's the same sign, but a different facial expression. It just gives a whole different meaning. So here is another example. These are two different classes. One is to help, the other one is can I help you? They look extremely similar, but what makes them differ from one another is the facial expression that is occurring over here. Now we are trying to extract those specific non-manual markers, and going through the domain analysis, we observed that these are some of the important, non-manual markers when it comes to facial expressions, rise eyebrows, twitch lips, and again, refeeding is the same set of stages, refeeding the information, the frames, and we extract a number of landmarks using the model, and these are the set of features that we extract for each and every frame. Now, we do some further processing in order to extract the features that represent specific movement of the eyes and the eyebrows or the lips, so that we can have a better understanding of the movement. And here is a 7 key frame representation of the sign. Your house is small, and as you can see over here, this is the behavior of the. Over here, you have a negative fall of the features, which represent, key frame number 6 and 7. There is a fall on this particular feature. And similarly, for a different class, you have a whole different behavior, which is kind of distinguishable from the previous class. Now, we run a sequence of experiments in order to analyze and have a better understanding of the performance of the system. We did it for 4 different classes, which are extremely similar to one another, differ from each other based on the facial expressions only. And these were the results. We did the same for 11 classes as well, which are kind of like similar to each other as well. The next set of 50 classes, which have some sort of non-manual markers or facial expressions included in them. And these were the results. And we run it for the whole database of 80 classes. Now, looking into the result, the blue line represents the performance with respect to when we included some sort of non-manual markers for the 2 different methods that we had proposed earlier, the cluster-based and chunk-based. And again, here's a different analysis, but yeah. This is, as you can see, this is just a cut section of the confusion matrix that we have on the top. The scattering represents the misclassification that has occurred due to the presence of non-manual markers, and that problem has been resolved by including the proposed method that we have had. Another method of testing the system was to check for the generalization ability of the system, where the test sample is a sample that has never been included in the process of training the system with the other samples. Right. So again, we run a set of experiments, and these were the results accordingly. There is what you see over here is the generalization ability. The blue bar shows the generalization ability of the system. And yeah, so thank you.
Okay, so for the entire data set,
yes,
you have experimented. So what is the performance increase when you included non-manual markers?
Yeah.
So non-manual markers, is it mean that you should take only face, or can you take some other modalities also?
In this case, we have considered the non-manual markers with respect to the facial expressions. So that is the morphemes, the rise of the eyebrows and all.
But body language also can be taken?
There could be like shoulder movements.
Yeah.
That would be the additional set of, yes, that is a very good question. Those would be the additional set of non-manual markers that could be added.
It's like you showed this shirt, right? So because
so this thing, yeah, I mean, in this thing we can just include it in the sign, but sometimes if I, let's say, if I say like big, all right, so this is big, I could have I could show my, like, raise my elbows, that will have a whole different meaning, it will add up.
So what is the performance increase in this case, in your experiment?
From by including the non-manual markers.
Yeah, non-manual markers.
As you can see, it's like almost 89.96, and that was from the highest possible, which is 68.8.
Okay. So another thing is that have you compared with the present models, these deep learning models?
Yeah. Yes.
Comparative studies there.
Yeah, we did it in the previous papers.
Paper, yeah.
Now these, our proposed method had a better performance, so it was not included on this.
Yeah. Okay, good presentation.
Thank you, sir, for such a wonderful presentation. Now I request paper ID 47 with the title Prioritized Buffer-Based Resource Allocation for Mobile Edge Computing Device to present their topic.
Good afternoon, everyone. My name is Shabir. I am from Amritsar Art and Sciences. I have completed my master's in computer applications. I did this project under Mr. Aditya Mukhopadhyay, who was our HOD. We have done project based on mobile edge computing devices, where we allocate task offering strategies to those edge devices. So problem definition is the rapid growth of internet usage and distributed computing resources of edge devices create necessity to have reasonable controller to ensure efficiency and utilization of distributed computing resources in mobile edge computing. The cloud computing based mobile applications such as AR, face recognition and object recognition have become more popular in recent years. However, cloud computing may cause high latency and increased backup bandwidth. Increased backup bandwidth means usage of more bandwidth, that is data consumption, because of the remote execution. To address these problems, edge computing can improve its response times and reduce the backup bandwidth pressure by moving the storage and computing resources closer to the mobile users. Computation operating strategies and resource allocation policies have become major setback in growing technologies. Therefore, we propose an optimization framework based on reinforcement learning, that is RL, to solve these problems. Main objectives of our research is minimize the delay in resource allocations, save the battery power of user devices, enhance transmission efficiency, increase reliability and decrease the error rate. Feasibility study, technical feasibility, we didn't gather any data set by ourselves. We have used online mobility data from product. Coming to economic feasibility, this is a simulation project and we are using Python for its open source. And also we are using TensorFlow for machine learning. That is also open source, so nothing to worry about that. Proposed system. The approach taken in this work starts from deep deterministic policy gradient algorithm. That is DDPG, a kind of reinforcement learning algorithm. We have made some enhancements. These enhancements, which we will discuss in this section, include prioritization of the experience replay. That is, if you see in the system design, there is replay buffer. What this replay buffer does is it stores the events that occur in an order, event 1, event 2, event 3. What we do is in this replay buffer we use an algorithm and prioritize those events. The DDPG algorithm uses a replay buffer which stores all the experiences, events for experiences, both are set. In this work, we use the replay buffer and prioritize the experiences stored in there by computing the TD error rate. TD error is nothing but error, which means we keep updating the priorities after every simulation. Our simulation starts with 6 states. Start to upload the task to the edge server. Request task is on the way to the edge server. Request task is processed. Request task is on the way back to the mobile user. Then it disconnects. then it takes then it another request. This is the table we have taken after running 5 simulations for around 50 minutes. We have increased the number of users from 10 to 30 every 5 intervals. We have used 10 edge devices, and these are the episodes that each simulation ran for. For 10 users, it ran for about 92 episodes. Mean of rewards is for every episode we get one reward. It ran for 90 episodes, so we can't include every reward. So we have taken the mean of those rewards. These are the graphs. After every simulation, it automatically generates these graphs and shows that more the number of episodes it runs, more the reward we are getting. Now these are the references. We have used around more than 30 references. We can't include everything, so we have added 5 main references here. All of these references start from 2018 because we can't take references, old references, because all those problems will be solved by 2018 itself. So I thought of taking references above 2018. That's all. Thanks.
Is there any specific scheduling algorithm you are using here? You have not mentioned anything specifically. What algorithm you are using?
We are not using any of them.
Slide of
Yeah.
your algorithm. Actually, it is less simple video. Okay. That it use.
Sorry.
What is this replay buffer will do? You know, already we have got so many algorithms, right?
Yes.
First come, first serve, last come, first serve,
Yes.
recently used algorithm. So many algorithms are there already available.
Yes.
Resource allocation.
Yes.
Here, what algorithm you are implementing to improve the performance? The
Oh.
objective of your project is to improve the algorithm.
Yes.
The performance of
Enhancing the
enhancing
yes.
the performance of the system. But there is no indication that what kind of strategy you are using to upgrade it.
Yes. All the experiences that it gathers is stored in the display buffer. It also stores the error rate. The lesser the error rate, it comes to the first priority. Like that, it's running. So we have not used any allocation of the running.
What way it is improved?
My question is, please understand my question.
What is the outcome?
Outcome. See, whatever you can give, based on one particular aspect you are considering, then it should have some outcome. So, in what way it is, your performance of the superior to others, then some kind of
That
comparison,
comparison,
you have to make. There is no contemporary work is proceeded
You,
here.
you might have got good result,
Yeah.
but that doesn't mean that that is the best one, right?
Best one.
So for that you have to make a comparative study, do literature survey, right? So those things are necessary to showcase your work.
Yeah.
So
So,
without that, the work is becomes
Yeah.
comparative or
Comparison study we have included the paper against here we have not included.
fine. Comparative study is important.
Right.
Compare your algorithm.
Any query from the audience? Just ask.
Any questions?
We can move to the next one.
Thank you.
Thank you, sir. Now I request paper ID 7 with the title A Two-Stage World Spotting Scheme for Historical Handwritten Devanagari Documents to present the topic in the online mode.
You are not going?
Sir, they are presenting from video.
good afternoon, everyone. University of and today I am presenting the manuscript paper titled A Two-Stage Word Putting Scheme for Historical Handwritten Paper Documents in a second international conference on data analytics and learning. So this is the outline of the presentation. So about this manuscript. So coming to the abstract, there exists a huge quantity of historical documents which are existing in many national libraries. These documents are very important. It contains many valuable information. So creation of digital libraries is very important. So word spotting is one of the methods that spots all occurrences of a given query word image of documents. It is a substitute method. It is an alternative method of complete transcription. Also, there exist many challenges in spotting words in historical handwritten documents due to the variableness in while writing. So, in this paper, we present a novel two-stage word spotting method in historical handwritten documents. In first method, we have used gradient, structural, and clarity features for representing the handwritten words. In second method, we use some set of low-level features which are used for representing the handwritten word images. And finally, for word spotting the words, we are combining the results of both the approaches. We have performed extensive experimentation on Devanagari manuscripts, and the results are promising in terms of accuracy and efficiency. Coming to the introduction of keyword spotting. So there exist many historical valuable manuscripts present in many. These are some of the historical documents. Word spotting details organic to attain, and also majority of the word spotting system which is applied for increased historical documents. The main challenges are, as the processing documents are historical, it will be affected from noises, stains may be present, created in lead through, wrinkles may be present, and presence of skews and unknown graphical symbols. Also, there may be the presence of complex degradations and cursiveness of the text. And the main challenging task is variations of the handwriting. The same word can be written in different format due to the change due to the variations of the handwriting. So this is the proposed overview of the proposed approach. In this initially, the input is the handwritten historical document. Then it is subjected to pre-processing method and segmentation method, where the words are segmented. The segmented words are stored in the database. So we have used two stages for spotting of words. Means for feature extraction method, we have used two methods. We have adopted gradient, structure, and unclarity method for extracting the unique features, Also, we have considered some back of low level features, some set of unique features for representing animated words. From both the methods, we are going to generate a rank list of words against the query word images. And finally, based on the ranked list, by comparing these two ranked lists, we will select a list of words which is the intersection of these two ranked lists. And finally, the result of the intersection of two ranked lists will be the final ranked list, which is used for sorting of words. So this is the proposed methodology. In step 1, the raw image has been obtained from scanned historical delivery document. In step 2, it is subjected to pre-processing operation as well as segmentation is performed. In step 3, feature extraction method is performed using 2 stages, using 2 methods. In both the method, the similarity between the given query word and the segmented candidate word images is compared, and based on the similarity score, the rank list is generated, which is used for spotting the words. For pre-processing, we have used contrast enhancement. We have performed binarization using the hybrid method by combining both Orso's global thresholding method as well as Aurora's technique. For strip detection and correction method, we have used horizontal projection profile method. Then for noise reduction, we have adopted morphological operations, low pass and median filters followed by Gaussian smoothing operations. These are pre-processing methods. And as in the memory, the word will be connected using the Shiroreka. As Shiroreka is present, we have used the connected component analysis technique for segmentation of words. And we have displayed the sample of historical data documentary and the thinner. The next step is the feature extraction method. It extracts most unique information which is used for describing a pattern. We have used a 2-stage method for word spotting. In stage 1, feature extraction is performed using gradient structure and concavity features. All the feature vectors of all the segmented candidate word images which are stored in the database, feature vectors are generated. Then for the given query word image also the feature vector is generated. Then it is compared with all the segmented word images using correlation equation. So based on these similarity score, a ranked list, the first ranked list is generated, which is sorted one, and it is denoted by CSE. Similarly, in the second stage, the feature extraction, it is performed using back of low level features. Here, the features we have considered are background to in transition, projection profile, upper projection profile, lower projection profile, the distance between these two projection profile, number of foreground pixels, center of gravity for the column obtained from the location of foreground pixel, as well as the transition at center of gravity. So similarly, for all the segmented word images, the feature vectors are generated, which is stored in the database. Also for text. So the data sets we have used is for other application, there difference by spotting top ranks for rank 5, 10, and 15 ranks in the final rank list. precision values, recall and failures are observed, and the overall performance of the system is observed in terms of mean average precision value. So also we have compared the performance using the individual methods by applying GSE method and back-up level feature method. Also using the proposed two-stage combined hybrid and corresponding graphical representation is also shown. Here we can observe that when compared to individual method, the proposed two-stage combined method will perform, it will give the text. Finally, by observing the values, by observing the results, we can conclude that we have, when compared to the individual approaches, the combination of the combined strategy of combining the statistical approaches, it will give better results when compared.
So it was a great presentation given by all the 6 teams. I thank Dr. Mohammed Javed for making time and being here. It was a great pleasure to have you, sir. Thank you. I also thank Ms. Dr. Mohammad Badshah, sir, for being here. Thank you, sir. So we'll be having 15 minutes of tea break. So I request you guys to be back within 15 minutes.
Good afternoon. So I request all of them to come forward. Come forward, please. Don't keep empty chairs. Come forward.
Otherwise, I'll stand there and give a cup. Yeah.
Welcome back, guys. Hope you guys are refreshed enough. I, Kunal from Computer Science and Engineering Department, feel extremely privileged and honored to be given this opportunity to welcome you all. So we are having our today's speaker as Dr. Pawan Chakraborty sir and Dr. Nagesh HR. So directly diving into the Dr. Pawan Chakraborty sir's biography. So, sir is serving as a professor and the head of the Department of Information Technology at the Indian Institute of Information Technology at Allahabad, and sir has done his higher secondary and Bachelor of Science in Physics, Astrophysics, Computer Science and Mathematics from Sri Aurobindo International Center of Education, Pondicherry. Sir has completed MSc in Physics. Sir has worked as Assistant Professor at Assam University, Silchar. And Sir has been working in Indian Institute of Information and Technology from past 16 years. Sir has interest in various fields such as human gait analysis, human prosthetics, biometrics, image processing, graphics and visual computing, graphical projections, robotics and instrumentation, and etc. So wholeheartedly and florally I request Dr. Manjunath Kotari sir to welcome Dr. Pawan Chakraborty. Thank you, sir. And we also have Dr. Nagesh HR sir with us. So directly diving into their biography. Dr. Nagesh HR currently working as a Dean Faculty Professor and Head of the Department of Computer Science and Engineering at Sayatri College of Engineering and Management, Mangaluru. Sir has obtained his BTech from NMAM Institute of Technology and MTech from NITE and PhD from National Institute of Technology. Sir has got more than 26 years of experience in field of teaching and research. His subjects of interest are computer networking, distributed computing, cloud computing, database analysis, cryptography, and etc. Sir has published more than 85 research papers in national and international conferences and journals. Sir has filed 5 Indian patents. Sir has delivered more than 35 invited talks. Sir has also chaired many sessions in international and national level conferences. He had also worked as a visiting faculty to National Institute of Technology, Karnataka, Surathkal and NIT. So now I request Dr. Manjunath Kotari sir to welcome our session chairman with your. Now I request Dr. Pawan Chakraborty sir to take over the mic and continue with the session.
Okay, thank you for a wonderful introduction. Well, I don't like to stand in one place, so I would prefer, am I audible now? Maybe I can keep the mic this way. Okay, so good afternoon. I know you all had a very good lunch. I also had a sumptuous lunch, and it's difficult to speak after a sumptuous lunch. Well, you can use that. But I would then need to hear me. Recording. So, is it okay if I speak this way? I think I'm audible. In fact, in that way, they will come forward. Okay. So my topic, as I said, there is signal to wisdom, and somehow or the other, Professor Nagabhushan has stolen my topic to some extent. So I in fact told after the inaugural session that you have already introduced my subject. So well, that gives me a little headway, and I will, of course, he has said what I'm going to basically talk, but what I'm going to tell you about is the different hurdles that you face as you move from signal to finally converting into information to wisdom. So I'll try to build the pyramid by giving you examples of different errors that we make on the path, and of course we should take care of these possibilities. Okay. How much? Hello. 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 Well, oh. Okay. So what I start is that nature or the world gives you the data which comes in a form of signals, which you use through a transducer, different types of transducers. You take it and sort of digitize it to get your data. So let me start by signals. And what you have is signal as I start as the base of my pyramid from where data is fixed. So what you have here is that a light shined onto a photoelectric device, which goes through an analog to digital converter, and then that converts it into a number. This number you store it in a computer, and then you further process this number to use as a data. It could be an image data, it could be any other voice data or any other thing. So you keep that. So these are a few design. You need to sometimes amplify the signal, and finally you need to pass through this. Now when you're having the signal, what you're doing is that you're sampling the signal. Now this is a scene where a helicopter has been videoed, and there is a problem with this video. Can you notice the problem with this video? The problem with this video is that this helicopter is flying without its propeller rotating. So what is happening is that the sampling, there is a problem in the sampling of the data. So data has been sampled in such a way that it has gone into sync with the rotation of the helicopter, and you have a false notion that the blades are not rotating. The blades are actually rotating, and it is not seen. So this is something called the Nyquist's limit, which tells you that you need to have at least 2 samples per this thing. Well, to explain to you in mathematical terms, I have a signal and I am sampling wherever these green lines are, and if I sample the signal at these green points at a regular interval, this is the final output I will get. You see that the frequency of the output is different from the input frequency. And invariably you will see that a lot of application is made in data science. In this thing, they take data say at 1 Hertz and then do a Fourier transform of it and get a feature in gigahertz. The data cannot have a gigahertz frequency. It cannot have any frequency which is less than 0.5 Hertz. So one has to be very careful, and some of these papers do get published, but technically it is wrong. So this is important because moving into frequency domain, one has to be careful. It's just sampling at a very high rate. do you have sufficient amount of sampling of the data? So this is first thing, and in fact, what you see is that if I sample it at the period of my signal, I get a flat signal, and obviously I'll say that I don't have any signal, I've got a flat data. Now perception is like the story of an elephant. You've got 7 blind men looking or touching the elephant, or I would change the story to 7 people or 7 probes are trying to measure some instrument, and they are actually touching the elephant in a dark room at different locations. So each one describes the elephant differently. You've heard the story of the elephant. So this is the elephant in a dark room. So one of them sees the trunk, so he says like a water pipe. The other says like a ear. So after going forward, so each one gives a different picture of the elephant, a different picture of the elephant, but each one is true, but it is partially true. He's not getting the whole picture of the data, he's getting a portion of the data, and he feels that the portion of the data is actually encompassing the whole of the data. So this is important when you're taking the data, how much of your undersampling, what is the sampling of your data, which is extremely important, and obviously can I use all the sampling, all the views on different, assume this to be different instruments taking the data, you fuse the information from all this instrument, and when you fuse it, it is like having a torch shining on the elephant, and that's when you get the picture of the whole elephant. So this is thing, and normally to err is human, we make errors, but to analyze is scientific. So what you have is a poor resolution with your data points. Then you use techniques where I can improve, have a better resolution, but poor signal to noise. Then further using techniques, I can further improve upon it, improve the signal to noise, maybe by adding much more signals together, improve the signal to noise, and after I improve the signal to noise, I can reconstruct the elephant so that I get a full picture of the elephant. So data comes with error, and one needs to, the moral of the story, needs to remove the errors or try to estimate the amount of error and the confidence in your data that you are trying to figure out. So here is raw data which you process and have, and finally you need to model it with some algorithm, or you need to have an exploratory data analysis, basically to visualize the data. Sometimes data is in numbers and you just can't figure out what is happening, so you need to visualize the data either through a graph or through some method. So that is, visualization is important, or explore the data is important. Now just to give you a CCD, which is now he has a few CCD cameras, web cameras, through which he is recording this presentation, and each of these CCD cameras come with a performance index or a quantum efficiency. So if I have a professional camera, it has this performance. A normal amateur CCD will have this performance. Earlier we used to use films which had a better blue performance, but this is the best films that you have. And so this performance index is not same in all colors. Now if I would like to get energy out of an image, a colored image, is not correct, because the performance of my detector is different at different wavelengths. And getting this, I need to calibrate it with a standard candle first, then only I can say that this much energy is in different regions. I come from an astrophysical background where energies play an important role, the color of stars play an important role, so therefore you need to calibrate the camera. So with standard candles. Okay, so apart from that, a detector, to make it much more sensitive, you thin the detector. Physically you thin the detector. When a detector is back illuminated and thinned and used, what you have is a fringing effect. You have used in your basic experiment like Newton's rings and other experiments you have seen. Similarly, you will have fringes which is coming in at a low energy level. Now, if your signal to noise is not very good, you are going to get these fringes in your data, and this is an artifact of the detector which needs to be removed. So this is an example. I had this image of stars and with this effect, so I modeled this zebra-like thing and subtract it out from the original image to get a picture of this kind. Now you will see what is this. There is a straight lines here. This is called leading. When your buckets, the charge buckets get filled up, and when you're reading on the data, it sort of creates a trail. It's a leak which is there. Basically, the readout leak which is there in many detectors. When you're actually picturing when there is a high contrast light which is there at night shot, you will see this bleeding coming in your mobile camera and other things. So this is bleeding which is there, which is again not real. That is because that is coming because of the reading out of the data. So these are errors in the data. Now here I am just going to give you a picture. This is a picture taken by the spacecraft Kobe, and it gives you the galactic plane in basically in microwave. It gives you the galactic plane. Of course, you get that. But on this galactic plane, you see that there is an S-like shape, a bluish thing which is visible. Now, is this real or is it an artifact? In fact, if you study further and find out its location, that is the location of your solar system or the disk of your solar system. That's where our planets are there. And this tells that the disk of the solar system has a lot of dust in it. And this dust is reflecting light, and this light is being shown here as this blue hole. This is basically from transformations you get this S shape while representing or visualizing the data. So this is again, light is connected with temperature. So this is a few things, and we measure temperatures of different things. Like our temperature falls somewhere here at the infrared. Similarly, star temperatures depend on the color of the star. So if you want to get information through color, I'll just go fast. These are some areas where work you can know by looking at the data. You can try to understand what is actually happening. So here you see, if I get a hot star and take a prism, I get a continuum. Now this hot star passing through a colder medium means part of some of these spectral lines of the atom, the atoms of this gas get absorbed, and you have got these spectral lines. So this is how you get the spectrum of the sun, where you have some line, the photosphere being cooler gives you this. But then if I take this gas, which then re-emits, and take any picture, I get only emission lines, and this is a third thing. So it doesn't have the continuum, but these are emission lines spectrum. So one studies in different way. So this is again, I have got a data, and here I see two humps. I get this data, and I see that there is a hump, but a single star is supposed to have a one black body temperature. You cannot have two temperatures. So what is happening then when you conjecture? And another thing that you observe, that this portion, as if someone has taken a bite out of the cake, and there is a gap here. So really what is happening is the ultraviolet region is being absorbed by the gas around the star, and then the gas is thermalizing and re-emitting at this region. So what you have is that this region reappears as a heated gas in this portion. So basically, by studying the data in these regions, I can sort of conjecture. I cannot see the gas. I can see a point source of light coming towards me. And if I take a spectrum of this, I get this whole story which is lying behind, or I sort of construct this story which is lying behind. Now let me just give you a plot, a simple plot. Here we know of different planets and their density. As you see here, this is the density of water, and you see Saturn has a density much less than that of the water. Saturn is massive, but since Saturn is spinning so hard, its density is less than the water. Sun's density is, Sun is bubbling, it's gaseous, its density is just that above water. But the closer planets have a higher density. That is understandable because they are more rocky, they are having, and these are gaseous planets, so they have less amount of density. So it is understandable. But now, in this plot, I am plotting the density of the moon and the density of the moon which is coming out here. The moon is close to the earth, and one would expect that the density of the moon would be similar to that of the earth. Men have gone to the moon, have brought soil from the moon, and the soil looks similar to that of the earth. There is no difference in the soil content or the composition of the soil of the surface of the moon and the surface of the earth. Then why is the moon less dense than that of the earth? So this gives you an insight on the story of how the moon was created. So this tells you that the moon was created only after the earth had cooled down and fractionated. The heavy elements of the earth had gone to the core of the earth. Fractionation in chemistry, you have done that. The core of the earth and the surface would have been of lighter material. When some object would have come close to the earth and chipped off a portion out of the earth, and that chipped off portion then from which the moon, our moon was created. So the chipped off portion certainly had lesser, denser material, and therefore it is of a lower density than that of Earth. In fact, the moon doesn't have a magnetic field also. So like compass we cannot use. Earth has a magnetic field, so we can use the compass. On the moon you cannot use the compass. So then light gathering power is also an important thing, that how much light can I gather and how much can I take. So here you see that first image, exposure, depending, you see less signal. So if I keep adding signals, I can get more and more signals, and you see this is that area having more light. So now what an experiment was done by Hubble Space Telescope. Hubble Space Telescope has been working for last 20 years in space and has been given wonderful data. Recently it has been, the Webb telescope has been placed and it is also giving you a huge amount of data, but Hubble has given you a lot of data. So there was an experiment on Hubble called the Deep Field. Now this Deep Field experiment is where they took a portion of the sky which practically did not contain any stars. So you took that portion of the sky and kept taking data. Each time the satellite, that the telescope would move, it's a space telescope, would move in that region, they would take an image and again add it to the original images that you have already collected. So for 15 years or for 20 years that they have collected images of that particular portion of the sky, and they co-added these images. And by doing this, you see that noise is random while signal is additive. So signal will keep adding while the noise will reduce by summation. So in fact, that is what was done. So this region was taken. You see that there are no stars, but this is the 4 cameras. 3 cameras were of same focal length. One was the high resolution camera, but later on they moved to the similar resolution camera. So when they took this image, you see that this is how it looked like. You could see countless of galaxies were visible there. So this empty space which we thought was empty is not empty. This is basically your thresholding. You go below the thresholding, you beat the noise to get actual data. So similarly, in this experiment, you have the Kamiokande experiment in Japan, which tries to see for proton decay and other things. It's a big experiment. One experiment at Polar Goldfields, which was done, and it has been mentioned in an American movie, 2012, the neutrino experiment done at Polar Gold Mines. So there also such big instruments were placed, and instruments. So Polar Gold Mines is not famous for the KGF Kannada movie, but there is also some science behind Polar Gold Mines. Well, you can see the galaxy in different wavelengths, and when you look at it different wavelengths, you can actually, because there's dust and clouds, which actually doesn't let you go deep into the data. So you can actually image in infrared, which can go deeper, the central region of this of our own galaxy, and the movement that you saw is the physical movement of the stars moving around the center of our galaxy, which is the black hole, which was image. This is how you can extract data or information out of it. So the same image you see that in different wavelength look different. Similarly, here you see that two scientists previously from the Bell Telephone Laboratory were trying to test an antenna, and while testing the antenna, in whichever direction they would put their horn. This is at that time the antenna was so big, and they got a noise, and they saw that this noise was uniformly coming from different regions. And then they read up some astronomy journals by Gamow, and Gamow said that if there was a Big Bang, there would be a primordial radiation field. And these people published their noise and got a Nobel Prize. While Gamow, who had developed the theory, did not get the Nobel Prize because they had done a practical experiment. This is Penzias and Wilson's experiment. And later on, you see that experiment has continued, and you get a wonderful black body, one of the best fit black body curves of the data. So coming from the signal, what you have is data. Data is nothing else but symbols. It is not information. When you say that data is information, it is wrong. You get is symbols, and if you do not properly collect your symbols properly, you tend to err. And it's like a big elephant, and if you don't know how to feed the big elephant, it's pointless having the big elephant. That's what also Professor Nagushan was mentioning about. So there is an outburst of data now, and one should know how to use it. So big data is not magic. It does not matter how much data you have if you can't make sense of it. So this is important. Now there is a crazy thing of collecting data. We keep collecting data and then we don't know and we have a mobile phone anywhere, we take selfie or we take a picture, anything that we like, we take a picture of it, then we don't know what we do with those pictures, so many pictures. Some of them you put in on your Facebook, but most of them go useless. So you get a lot of data and then you cannot select from the data what information you would like to place. So now data, it's a wave, it's a tidal wave, a tsunami of data which is coming, leading to data flood. So more data is generated in banks, telecoms, other business transactions, scientific data, astronomy, biology, as many people mentioned, medical sciences is producing a lot of data. Astronomy has been producing a lot of data and it is free of cost. Because medical data has a lot of ethical issues and other things, it doesn't come for free. You need to have an MAU and other features to do it. Then you have got web, text, e-commerce data and other things. So this is a cartoon from a biblical cartoon where Noah has built this ship and then he says the ship is too small. And what are the animals you have got here? Hadoop, Python, pig, R, SAS. These are terms or terminologies used in data science or programs used in data science now, and these are the animals that you need to carry. So what you have is how to develop a data strategy for cooperation and not conflict. So you have a huge amount of data which are numbers and other things which you need to really order them. So you need a proper way of sorting them and placing them in a proper sorted manner. Otherwise, you're gone with it, you just can't work with the data. So organizing the data is a thing, then visualizing the data comes, and then sharing the data. Well, now there are different algorithms or different ways of representing the data. This is an HDF5 mind map. Similarly, you have, this is one of the recent methods used by NASA and biological sciences for storing data, which is of a different multi-dimensional data can be stored in this manner. So here you have this, and so after data comes, from the data, from the symbols, I manage to answer to questions who, what, where, when. So when I manage to answer these questions, that is when I get to information. So from information, I turn to knowledge when I answer questions, answer to how things are happening. Okay, when I manage to explain them, how things are happening, one is why things, where, what, when, to how things are happening. That is when information becomes knowledge. And of course, science is knowledge at work. So data moving into information into knowledge. Knowledge discovery is the central theme of science. Knowledge discovery in database. So these are things. So now coming back to this thing from knowledge, we move up to something called understanding. So understanding is that when we say that we have been able to appreciate knowledge, and we say why things are happening. Okay, so then we are appreciating the knowledge and we are understanding, and when we have assimilated the knowledge and evaluated the knowledge into evaluated understanding, we call this wisdom. So this is the basic pyramid of data science, or how data science would like to move from data. So the basic 4 pillars of data science is databases, statistics, visualization, and machine learning. All this is connected with data mining and knowledge discovery. And the difference between them is very fuzzy. Well, I'm just going forward over this region. I just since there's lots of time. Now, data training. What you have is sometimes you create a distribution and you see how the data gets concentrated into clustering, and we try to train the data so that I can now sort of decipher the different data. So when I train the data and the process after training, I can then say that it has got 3 centroids, and I can separate it out as the 3 different features in the data which we use, say, as machine learning. So primitives of robotics or machine learning comes from sense, plan, and then act. So you have this sensor data, then you have got information, and then you act according to the information that you have planned. So this is a robotic paradigm. So where you have 3 different ways. One is the hierarchical, another is the reactive, another is the hybrid method of data intelligence. So here is the hierarchical, where you have both sense, plan and act, and then reactive, which is just hardwired with sense and act. Another is a hybrid, where it sometimes plans, sometimes you don't need to plan. You make it a habit. You train the data. Once trained, you don't need to plan for the data. Okay, So planning is something which is a hybrid thing. So you've got a basic thing is that you have a real world where you're sensing the data from the real world, and then where you go to perception, this now is in your computer. You perceive the data and you create a world model of the data, you put in your goal which gives you the behavior, and based on the behavior you take an action. Right. So perception established correspondence between internal world model and the external real world. So behavior uses the world model to generate action to achieve goal. So here you have got observed and finally to get to the action of the data. So one is external and another is internal to the computer. So can machine be intelligent? So this is a domain called the Internet of Things. Can I make smart cities, smart house, smart things, which is now we hear, smart watches, and this is where it's collecting data from different domains. So basically this is the father of IoT. He says he believes that IoT could turn the world into data that could be used to make macro decisions on resource utilization. Information is a great way to reduce waste and increase the efficiency, and that's really what the Internet of Things provides. So this is a new domain. Now, initially I like to show his picture because being an Indian, Pranav Mistry has done a lot of pioneering work in trying to get information out or a device which will give him a different information. So so here you see he has got colored finger spots through which he has made these this data where he can sort of draw on different boards and create this thing. So here he can zoom in, zoom out. He has a projector. He wants to take a picture. He just makes a hand gesture, and there he clicks a picture, and he can go click a picture, and say for instance he wants to now sort this picture. He goes near a wall and he sort of places them, and he sort of organizes his data properly, and he is sort of placed it in the right location. Now, supposing he wants to dial a number on the phone, the projector gives him the numbers. Now he can sort of dial a number on his hand and make a call and then go. So now he's gone to the stores and he reads the barcode of the material, and then it tells you the details of the material. Basically you can hear the details, or the details can be projected on the material. Now he opens the book. Before he opens the book, the title of the book can be read and told about what the book is doing about, what the book is about, what is the rating of the book. As you see, the stars will appear on the rating of the book, and it tells you some description of the book that he is going to buy. Should he buy, or what is the recommendation of the book that you have. So this, he named it as Sixth Sense. Supposing he has a news headline, reads the news headline, get a YouTube video out of that, and gives you the thing. So he recognizes the person and is a student in the media lab, and it reflects things on his thing. So here you have, he now wants to go and he wants to know if his plane is on right time or not. He shows the ticket to the device, and the ticket, all the details about the flight, and he can do web check-in, and everything can be done just by showing the ticket at the location. So this is one of the domains that he has worked. He named it the Sixth Sense. So it improves performance, reduces cost, creates innovative services, new revenues streams are there. So a few applications of IoT. I'm not going through this details. This is one of the experiments that I was interested when the Farm Bill came. Unfortunately, Farm Bill was a very good bill, unfortunately, some vested interest that this bill did not come through. So this is an app which some students can develop. A farmer can go with a mobile phone around his field, and he goes to different portions around his field, and as he's moving around the field, like you run, you can get a GPS track of your location, and through this GPS track you have made a contour of your land where it exists. And then in that app you say that you're going to grow these crops at this time and post it. So you have got these big shops now, geo shops and other things, who would like to have your product. So they say that, okay, I'm interested in your product, I will not give you a loan, I'll give you 75% in advance, okay, and you can build it. I will insure the product. If it goes my money, it is my money, so I will insure my money and give it to you. The farmer gets the money, and through a drone, a drone can be shared between the farmer, the big company, like Big Bazaar doesn't exist now, but GeoMart and others can sort of get directly from the farmers, and they can inspect their product and get the product out. So this is a wonderful thing of smart cultivation and smart farming, which can be implemented very easily. So these are the different domains. So basically, these are areas where smartness, IoT starts working, and this is medicine, garbage collection. This is an important thing for tagging the instruments. Recently, from Namibia, a set of leopards or cheetahs came to India, and they were given a collar tagging, and you could trace the movement of this through satellite. You could trace the movements, how these cheetahs are moving across these regions, and this data could tell the habitat how the cheetahs are behaving remotely. So this is the collar that they have, the digital collar which allows them to do that. So the health people take how many steps per day you take, all this data information. So coming back to this 4 pillars, let me go into visualization of the data. How much time do I have? For 10 minutes? Okay. So I'll just deal with a few points of visualization before I end my lecture today. So let me say, visualization of data is important, is that my data could be multidimensional. There are ways that I could have made multiple attributes to the data, and it could be multidimensional. So how do I visualize and represent multidimensional data? We know how to represent a one-dimensional data, two-dimensional graphs. 3 dimensions we can represent in a 2-dimensional paper by taking a photograph. Photograph is nothing else but 3 dimension represented as a projection, which is generally a perspective projection, which is there. It could be an orthographic projection also. So we can represent 3 dimension into a 2 dimension, but can I represent a 4 dimension in a 2 dimension? How, and is there a method of doing that? So let me see that. Okay, how can I do? So what do I have? 1 dimension is a 0 dimension, a single point. When we double it, it becomes 1 dimension. When double the point. Now further double this point, I get 2 dimensions. Right? So I can represent the data in 2 dimensions in this. And then again I double the point again and connect these points, which gives me a 3-dimensional representation. So now here you see I can represent this 3 dimension in this 2-dimensional image, 2-dimensional screen. Now further, can I go forward and represent 4 dimension? What will I do? I will again reproduce these 4 points, duplicate them, and find a connection between them. So here I have got the 4th dimension where I duplicate them, I connect them. Now I can see 3-dimensional objects in the 4-dimensional plane. It's a little complicated, but one can visualize this four-dimensional data and showing it as a three-dimensional objects moving in the four-dimensional coordinate system. So further again, I can move forward from, so this is having one cube and representing it in 2D, so I need to represent another direction, make a direction, and I represent that. So now, let me just show you a video of how these multiple dimensions are stored. So can I...
With machine learning, the computer isn't told the meaning of these dimensions. It just sees them as numbers. And it sees each set of numbers as a data point. But by looking across all of these dimensions at once, it's able to place related points closer together in a high-dimensional space.
Words are treated as high-dimensional data points. Instead, we've shown it millions of sentences as examples of how words get used. Here's a visualization of the results. We're looking at a subset of words that the computer has learned about. Each dot represents one word. Each word is a data point with 200 dimensions. Using a technique called t-SNE, the computer clusters words together that it considers related, and clusters form based on meaning, even though we've never thought it the meaning of words. Here is a cluster of numbers, months of the year, words related to space, people's names, cities, and so on.
If we search piano, we can run t-SNE only on words related to piano. We get clusters of composers, genres, musical instruments, and more. Machine learning is pretty complex, so we've been experimenting with ways to visualize what's happening.
Okay, so this gives you an idea of how multidimensional data is used and gives you a lot of further information. Here is further visualization of three-dimensional data. This is below is an image of our space, and up is your t-SNE, which is word information. So the visualization looks different. Looking at it from different angles becomes an important task. Sometimes you need to visualize it and connect the data. How do I connect the data to get a thing? So this is what you see. It looks like a spider. Is actually the Linka cluster from where our solar system, our own galaxy is part of the Linka cluster. And while this is the top one is of words. Similarly, visualization of GPS coordinates when you move in a car. So these are few other visualizations where you do a CT scan, and from the CT scan I can generate other dimension of the data. So when a body is sent, and then you can get a three-dimensional picture of the skeleton from this CT scan images. Similarly, an MRI image where you create a resonance. As you go into it, a strong magnetic field is sent, and then at different frequency or different body parts resonate, and looking at it you can get layers of your body without chopping your body or without getting a cut. You can know different parts of your body separately and get a three-dimensional picture of your body parts. And so this is medical imaging has gone to that extent. This is projection. So what it is doing is imaging from all directions and applying the proper projections so that you can create a layered image of the data. So this is how fusing information from multiple sources can give you dimension. Like depth finding in cameras, this is being used in medical sciences, and it is being very well used in medical sciences. So a picture is worth 1,000 words, but the world that we see has a depth, 3D, while the picture is mere a 2D projection. So can I get a depth from it? Now what Einstein, a quote from Einstein which says, one picture is worth 1,000 words. A similar quote by a scientist much later than Einstein said, a picture is worth 1,000 words and uses up 1,000 times the memory. So thank you very much for patient listening. So I went again with this thing. We are only seeing the top of the iceberg, and we are moving from signal to data, data to information, information to knowledge, knowledge to understanding, and finally to wisdom. Thank you very much.
Audience, any questions? Audience, any questions?
Is there any camera, latest camera for having multi-dimensional?
Multi-dimensional data camera, of course, if you takes away a projection. There are cameras which we use. This one was Kinect, but now they have stopped producing Kinect. They are replacing Kinect with some other feature which was there. Kinect is an infrared camera, infrared projector, and an optical camera. Three things where you actually focus two dots and try to create a point cloud with it. So that is presently not. Presently they are coming up with a higher version of it. So I don't know presently which is there. But you have got LiDARs and other costly equipments where you get a three-dimensional depth information. Or you can actually, using machine learning and using one camera, moving camera, you can create a depth information. One of my PhD students is working on how to generate a depth image with a single camera, moving single camera. If it is moving, how does it create a depth information? Or with multiple cameras.
Any other queries or questions?
What are the different visualization methods? We have found some explanatory data analysis using Python, some kind of simulation and other kinds of technique, some kind of bar chart and code.
Yeah. See, there are different ways.
Any modern kind of visualization tools available as an open source?
Open source Python has a huge visualization tool, but there are some programs like Tableau. There is a program called Tableau, but it is a paid software. But for 15 days or so, you get it for free. So you register in one name and then register with the other name. That's how we use it to teach Tableau. It's one of the best software for visualization. But Python you will have to actually program. And if you know basics of graphics and look at vector and other things, one can generate it yourself, the different visualization.
But it's very difficult to visualize certain data.
Yes.
Data.
Especially 4D visualizations are 4D 4-dimensional visualizations.
But see, I have given up to the 7th dimension you can visualize, but it becomes complicated.
Correct.
You need to actually have visualize it on a computer, which you can have a moving thing, say that this is in this 2-dimension within or 3-dimension within the 7-dimension. So you can since we are living in a 3-dimensional world, to visualize anything more than 3-dimension makes it very little difficult. So, but one has to practice, or what you do is that you keep some of the dimension as constant and you vary the other dimensions. Three dimensions you can vary and look at it.
So according to you can go up to how many dimensions?
See, this method can allow you, each time you double the number of points, you go 1 dimension higher.
Okay.
So only thing is that when I have a cube, I can create a hypercube. Then from a hypercube, I can create a hypercube. Only thing is that the linking of points, you have to map points from one to the other, has to be done properly.
Mapping is should be done properly.
Visualizing the mapping becomes difficult. So only thing is that you sometimes need to rotate it.
Yes.
Even 3D, I cannot visualize anything unless I look at it from different angles. You've seen some of these, I need to rotate it and look at it from different angles. Like any 3-dimensional object I see, I rotate sometimes, or when I'm buying an apple, I rotate the apple and see it from different direction. That's when I know the apple is perfect.
I think people having some good knowledge about computer graphics visualization becomes
computer
very easy
graphics
for
is
them.
a requirement for visualization.
Correct.
Because the techniques which is taught in computer graphics is they look at vector.
Correct.
And there you're creating a virtual 3D from which you're creating a 2D image instead.
Correct. So one video you have shown that the scientist of 39 years old, you saw that one.
Which scientist?
That particular technology. You have shown one video now.
Sixth sense, that is
Yes, sir.
Pranav Mistry.
Pranav Mistry. What technology he is using?
He is having a small computer and he has a projector and a camera. So he has devised a small device here on his chest, which is a projector and a camera. Yeah. So this is this device that he has. He has a projector here and a camera. So the camera is looking at his hands, and accordingly he has this computer here, or this is connected through Wi-Fi to a larger computer which is doing the processing. So he has done using simple techniques. He was working in MIT, but then he didn't complete his PhD. He has become a CEO of Samsung wing of innovation. YouTube is filled with his videos. Pranav Mistry. You can Google it and you will get his. A boy from a village of Palampur in Gujarat, from a very humble background, doing wonderful work.
Interesting.
I think with that we'll conclude this session. So it was a wonderful session. I think all the audience have enjoyed that session. I thank you very much from the organizing committee.
Once a great man whispered, feeling thankfulness and not expressing is like a wrapping present and not giving it. Today, I take opportunity to put all my gratitude into words. On behalf of management and organizing committee and all students, I would like to thank our today's speaker and session chair who has graced us with their presence and guidance. Thank you, sir, for sharing your precious words with us. Now I request Dr. Mohidin Madhusha sir to present memento as an expression of gratitude to the Dr. Pranav.
I'm not Pranav Mistry, I'm Pavan Chakravarti. I was fortunate to have a computer at a very young age, so I'm not as from a remote place as Pranav Mistry.
Thank you, sir. Now I request Dr. Manjunath Kothari sir to hand over the member as an expression of gratitude to the dead session chair. Thank you, sir.
Nothing is more expensive than a best opportunity. And we are really pursuing my bachelor's in engineering. It is a possibility. It is a possibility to increase our best allies, Dr. Arasana F. and Dr.
of BMS Institute of Technology and Management. So, has completed his PhD in Computer Science from Bangalore University and his post-graduation diploma in Cyber Law and Cyber Forensics from National Law School, Bangalore. His area of specializations being computer vision and image processing. So, has a total teaching and research experience of 29 years with 3 patents published. So, is a member of NBA expert visiting team and NAC field team as an observer as well as a visiting team. He is also a chief coordinator of AICTE Bangladesh team, mentoring university and 2 engineering colleges. So, is also the member of Academic Council, DITF Ballari and Research Review Committee, PTU Ballari. So, is a co-principal investigator of PST RFPR sponsored international collaborative research project with Moscow State, Russia for mathematical models and morphological analysis-based algorithms for image comparison and classification and computer vision system during 2017 and 2019. And also, he's been part of PST RFPR sponsored international collaborative research project for spatial modeling of human faces for real-time analysis and classification during 2009-11. So, has also visited Moscow State University, Russia to discuss progress of BST RFPR collaborative project. He also has membership in major professional bodies like being a fellow in Institute of Engineers, life membership in Indian Society for Technical Education, and is also a member board of studies for BTU and 12 other colleges and private universities. And is also the member of Academic Council, Ballari Institute. It's such a great honor to have you here, sir. I welcome you, sir. Now, I will ask the ma'am to gloriously welcome our respected dignitary, Dr. Dept Swamiji. We also have Dr. Arun Anand M. as Associate Chair, who is the Associate Professor at AIET Universities. His area of interest being machine learning, deep learning, image processing, and mathematical modeling. So, has completed his PhD on Information and Communication Engineering from Anna University. So, also has an highly commended thesis on image forgery detection. He is a EC Council certified ethical hacker and computer active forensic investigator. So, has a total of 10 years experience in teaching and research fields. He has also completed his MTech from Kalasi Lingam University, Tamil Nadu, and reviewed Springer and Scopus Indexed Journal, and has published many books, book chapters, journals, and Indian patents, which marks up to 50 publications. Many of those papers are published with CSE, Springer, and IEEE. He has also attended many venues as guest lecturers on cybersecurity and latex media communication. I welcome you all to be sir. And now, Now, let's begin with the paper presentation. The protocol being presentation is allowed for 12 minutes, question and answer session is allowed for 3 minutes, and a warning bell is given at every 10th minute, which marks the end of your given time. Now, I would like to ask paper ID 32 with paper titled Machine Learning Based Pattern Recognition Models for Classification to present the idea. And I ask paper ID 44 to be ready.
for image recognition and classification. And my presentation contains like abstract introduction, literature survey, pattern recognition model, methodology, machine learning based remote classification, conclusion and references. Abstract says, recognizing pattern and identifying different objects by machine learning machine using human intelligence is a challenging issue in real world. As we know, machine learning techniques help machine to achieve automatic, manual tasks and advanced technologies. The applications of machine learning and pattern recognition are medical analysis of medical images, tax return to audit, automatic inspection of printed circuits, etc. We are presenting a paper on different machine learning techniques based on pattern recognition and approaches to recognize an object. Also, this includes various modules of pattern recognition for image analysis and recognition with aid of machine learning algorithms. Introduction. The pattern recognition, as we know, pattern recognition means classification of patterns into subclasses or objects. As we know, pattern recognition can be done in tools like 1D or the recognized pattern can be in 1D or in 2D. The main aim is to import some authority to the machine to work certainly like human. Pattern recognition can be done in two ways, that is supervised and unsupervised way. Supervised learning algorithm has labeled data, whereas in case of unsupervised learning algorithm has unlabeled data. The pattern recognition is a kind of machine learning, machine intelligence that plays a crucial role in machine vision system. That is one of the examples, like for example, like optical character recognition, or in case of printed circuits, as we mentioned in the previous slide. Then moving on to the next slide. We have some applications of machine learning like face detection, biometric, as I said, printed circuits, data analysis, medical image, and etc. We have a pattern recognition model which is having some flow, which has sensor pre-processing and enhancement, feature extraction, and the pattern recognition algorithm. Sensor, as it means, it collects the data, and pre-processing may involve filtering of data, enhancing, segmentation it involves, and in case of feature extraction, it is going with the machine learning techniques to extract feature extraction techniques to extract the features which are required for the further processing. The pattern recognition part has different algorithms like classification part using clustering algorithm or regression algorithm. Then we have went on with literature survey for pattern recognition using machine learning with different types of like as I said, it may be an image. We have went on with the general image. We went on with medical images, video surveillance, and we also went on with one of the comparison between main theoretical and practical results. As we can see, we have got good results as compared with the different techniques. And the next pattern recognition models will be explained by my co-presenter.
So coming to the pattern recognition models, there are four types of pattern recognition models are there. So which are statistical model, structural model, template matching model, and neural based model. So let me begin with the statistical model. So in statistical approach, the pattern recognition is done in the form of features. Statistical approach is good when dealing with the noisy patterns and grammar defining. By selected features which helps to predict and recognize the probabilistic nature and which form the classes. If we go through the supervised techniques, where a discriminant analysis approaches for dimensionality reduction, which defines each pattern class and performs the classification function. In the case of unsupervised technique, where a principal component analysis technique used for dimensionality reduction, which calculates minimum distance from various unknown factors. So as coming to the structural model, so structural model is necessary in order to recognize patterns with strong structures for which statistical model is a bit difficult to be used in the recognition. And structural model is necessary for complex pattern recognition such as multidimensional entities. Patterns which are hierarchical in nature are categorized further into subclasses which are directed by subpatterns respectively. Structural models are used in the application areas like textured images, image interpretations, so that at that places. And as coming to the template matching model, so this model is used to discover the similarity between two images, and the recognized sample is matched with the stored templates. And the efficiency of this model depends on the stored templates, which means this model used where some of the data used to be kept to compare new one or the resultant one. This model fails in case of patterns in out of shape. And coming to the neural based model, so these are efficiently used in the classification because they are composed of parallel structures, that is surveillance called as neurons. So here there are different types of neural networks are there. Based on the task of classification in pattern recognition, such as artificial neural network and fuzzy models, kind of models were used. So with to improve the performance of the neural network model, we can increase the number of brain layers in the model. So as observing all the models, we get to know that not a single particular model gives a good performance to all the databases. All have the disadvantages of which gives only the single advantages only. So that many researchers have gone through the combining of two or more models or techniques, so that they have got a good performance, so that they have gone through the hybrid model. So this table shows the comparison of different pattern recognition models. So here every model has a disadvantages. So these are used based on the application areas like statistical use in the data retrieval purpose, structural is used for character recognition purpose. So every model has used depend on the different task. So this model, this slide we will going to present.
The methodology of machine learning part says that data acquisition, pre-processing and feature extraction are pattern recognition. Hence we use the large number of data set, we need to add an extra step, that is normalizing the feature to normalize all the features which we want to extract, and the data extracted is next process for training and testing process. Then these classification output is measured based on the performance measuring parameters like accuracy, sensitivity, specificity and recall and precision. Accuracy says how accurate the model can classify the data, and sensitivity says how correctly positively identified data, and specificity says the negatively classified data set. We have gone through some articles based on machine learning and pattern recognition, in which this compares, which shows that only using single models what the results we can get, and by using hybrid methods, like if we use ANN, like backpropagation methods with some machine learning models, we can get the better accuracy and picture of output segmented image like that. And this literature survey shows that using hybrid model is better than using single model. For better pattern recognition, we can use the pattern recognition with machine learning, and this hybrid model. Conclusion: this paper presents the review of some possible types of models used to pattern recognition and classification with importance of best classification. Different models are suitable for different patterns, such as statistical model is better for noisy images, and structural model is for pattern recognition, patterns and fuzzy logic for unknown shapes and recognition. conclude that hybrid models are most efficient way to get the good classification when compared to the individual section, which we have seen in the architecture that using only one model, that is SPM model, like PNN model, we can get the accuracy of 97, 99, 92, 92 and 98 only. But with the use of hybrid models, we can get up to 98.9 accuracy and good results. With the aid of machine learning algorithm, we can design a best suitable pattern recognition model to our issue of using single model. Research is also extending this scope. It is already much research has done using the hybrid models. Fuzzy models has capability of stable learning and strong resistance to noise. This is an example that pattern recognition models are compared with the machine learning to get the accuracy, highest accuracy. Finally, the work can be extended by using the proper combinations of pattern recognition algorithm and machine learning algorithm. These are the references used in that.
It's okay, we have seen your presentation, it's fine, which is well suited for 12 minutes. You go through slide number 7 and the literature survey. If you look at the literature survey, so it is not giving any, you cannot draw any inference here. Which year, whether the year of publication is not mentioned.
Sir, we have done survey up to from 2015
No. Year is not mentioned. See, when you do the literature survey, it is at least to the current year it must be there, right? So now we are at the edge of 2022. So which paper is from which year is not mentioned?
Sir, you mean to say that we have to mention that?
Yeah, then otherwise how do you say that it is complete literature survey? So can you tell me that Geon Hong, so which year paper it is?
So actually we did it in 2016, sir.
So which paper is from 2021-22? No, recent is not well-defined term. Recent for you need not be recent for me. Right? It must be with you must mention the year of publication and also which journal it is. That is also most important. Okay. And so this is first part of the question. Second part, it is data set. So what is the criteria to select the data set? You talked about data set in future, right? Future slides. What is the criteria to select data set for particular experimentation? And the data set na ಏನು select ಮಾಡ್ತೀರಾ ಅಂತ?
Based on the features, we can include the features. If you are, for example, if you are taking healthcare, that is brain tumor, we can have the different classes of data sets.
Data set, how it should be, size, etc. Challenges, slides.
Should be in the image format we are going.
No. So my question is, how the data set, sometimes if you select the data set which is too simple, your experimentation may not be robust. Right? Those things you are supposed to cover, right? This is survey paper, right? So you made the survey. So but survey, literature survey, you must do methodically and year of publication must be included and you must elaborate on the observations with respect to each paper must be made available. Otherwise it is not complete. Anyway, the presentation is good. Thank you. So audience, you have any questions?
So you have dealt with the pattern recognition.
We have dealt with pattern recognition and deep learning. Both comparing the pattern recognition is an image processing technique. So you are comparing this with CM kind of machine learning and other things.
Sir, we are combining both.
Both combined.
We are saying it has hybrid, like combining pattern recognition and machine learning.
So you are doing both.
By using single model, we didn't get a good performance. There are every model has disadvantages. So as combining
Suppose you are using two different techniques in the same domain, you can say that it's hybrid. It is a two different technologies that image processing. First you are doing image processing technique, pattern recognition. Then you go for training the data set, testing the data set, something like that. But if you are CNN, using CNN, right? You are, to my knowledge, I am telling that it is not considered to be hybrid. You just think over that. As our rightly mentioned that go by the literature survey as according to history, right? From which paper to which paper. Then it will be nice, the paper will be nice. Thank you. Good presentation.
Thank you. Now it's paper ID 44 of paper titled Medical Image Compression using Huffman coding for TIFF images.
Good evening, everyone. I, Rekha Vinata, this is scholar, Department of Computer Science, Karnataka State Akamadevi Women's University, Vijaypura. Today I am presenting a paper which is entitled with Medical Image Compression using Huffman coding for a TIF images. Okay, the contents are introduction, the application of image compression, method and workflow, result and discussion, then conclusion. Firstly, a medical imaging. Medical imaging is nothing but which will allow the doctors to get a better understanding about the human body issues and also make a better diagnosis to help the doctors to make a better diagnosis to the patients. Here benefits are better diagnosis, complicated surgeries, affordable healthcare and services, and also it is safe and effective. I have chosen TIFF image. The medical images are come in different forms, that is JPG, PNG and DICOM forms, but I have chosen TIFF image because it is having a highest, it is not a compressed while capturing and it preserves more quality and at the highest resolution. It is having it requires more storage space. To handle such type of images, we have many challenges, that is storage requirement and the time consuming. To store such images, we need a lot of storage space, as well as when we want to transfer it from one place to another place over a network, it will take a lot of time. So for that, we need an image compression. By compression, we can send the particular image from one place to another place. Image compression is nothing but it is that is remove unimportant things from an image at up to a threshold below the threshold value. And it is the using of this medical image compression is effective for an effective storage and transmission as well as cost effective. The most important sector where this medical image compression is used is remote area. That is, remote area is nothing but a rural place where the professional doctors may not available for diagnosis. So they will go with the local hospitals and the local doctors will provide some basic details about the patient to the city hospitals. Using those basic data, they will conduct a video or audio conference with the patient to the expert doctors. Then these all data will be stored in some centralized database that can be accessed using any apps, that is mobile apps or web interfaces. So in an emergency cases, the super special hospital can access these data and operate the patient at a remote area only. Image compressions are categorized into two types, that is lossy and lossless. In a lossy compression, the name itself says that it may lose, while compression the data may get loose at some extension. In a lossless, this type of data we are used in some certain places where data is critical as well as the layers of information cannot be acceptable. For example, in a medical field, each and every bit of information is very useful for diagnosing the patients. So, I have selected the lossless compression method, that is Huffman coding. The wavelet transform that is analyzing a signal into different frequencies at a different resolution, which is also known as a multi-resolution analysis. Decomposition, the quality of an image depends on a number of decomposition, or that is, it consists of mainly of two parts, that is high frequency and low frequency. Every image is divided into four parts, that is approximation detail, vertical detail, horizontal detail and the diagonal detail. Except the that particular approximation detail, all other data are discarded, and again that approximated details are sent to the next levels. Thresholding, it comprises the reduction of a selected wavelet coefficients in order to separate the or remove the noise from an image or a sequence. There are two types of thresholds are there: hard threshold and soft threshold. Hard threshold is nothing but where we are selecting a threshold value. If the threshold value, the pixel values are greater than threshold value, then those pixel values are keep it as it is. If the pixel value is lesser than the threshold value, then make it as a 0 or discard. Another one is that is soft threshold, where the whatever the pixel value is there, if it is less than threshold, that will be made as 0 or removed or discarded. But greater than threshold will be get subtracted from the threshold value. So Huffman coding is the pixel that occurs frequently are encoded with the lower numbers of bits. The workflow is loading a AIET image using a image equalization technique in a MATLAB and performing a pre-processing operations. Then wavelet decomposition is carried out using a DP1 or a hard wavelet of 2 levels. Then applying the varying threshold values, that is 10%, 5%, 1% and 0.5%, maintain the highest coefficient value while eliminating the all other small coefficient. That is, we are using a hard threshold here. After that, after these quantified coefficient values are, again the Huffman coding technique is applied for these quantified coefficient values. Then the different criteria were used to assess these image quality, that is compressed image quality, that is PSNR, compression ratio, then MSE. The result is here, 2-level decomposition and the different threshold values with the compression image. The data will be collected from a Canal database and the experiment is done in a MATLAB. This is the result with the compression ratio, PSNR and the MSE. This is the compressed image in a bytes. That is size of at the beginning original size of an image is 41. After applying the various threshold values, after coding technique, then it will be 18 KB, 16 KB, 12 KB and 11 KB. So how you decrease that particular percentage of a threshold, the particular size of an image is also reduced, but the quality will not be good. So we will select the highest threshold value itself. As a result, the Huffman coding is an effective method for compression. To increase this effectiveness, we also included the Dept wavelet, that is DP1 hard wavelet, to improve the compression ratio and PSNR value, and also we have assessed the performance of an image quality using peak signal noise ratio, compression ratio, and mean square error. These are the references which I have referred for my work. Thank you.
So this paper is experimentation paper or survey paper? So you made experimentation implemented by using MATLAB. Okay. Yes, so I have a couple of questions here. So what do you mean by threshold and how to fix the threshold?
Threshold is nothing but it is a value which has been defined to get the highest coefficient values. Except whatever the threshold value is there.
What is the criteria to select the threshold?
It is
identify
No,
the
with respect to your experimentation, how you fix the threshold?
that is, I have firstly I have experimented with all the 50 from 50% to all I have selected that is all the threshold values. 50, 40, 30.
How many?
From 50 I have started. 50% I have started. From 50 I have concluded.
You started with 50?
Yes.
Why only 50?
Because we cannot go with more than 50 for an image.
Okay, so you cannot go and
No, it is not like that, but for an image quality, we cannot take that much risk in a medical image operation.
so how about 40 then?
After that, when I experimented that particular threshold value.
No, what is the scientific way of going with threshold? Is it random?
Yeah.
Is it random or
No,
not?
no, sir. I have experimented and then I have
Yes, you have experimented, but before selection, how do you decide where to start? ನೀವು ಎಕ್ಸ್ಪೆರಿಮೆಂಟೇಷನ್ ಮಾಡುವಾಗ ಎಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀರಾ?
That I have started from 50%.
ವೈ ಅಂತ ನಾನು ಕೇಳ್ತಾ ಇದ್ದೀನಿ. ನೀವು ಅದಕ್ಕೆ ಏನು ಅನ್ಸುತ್ತೆ ಕೇಳಿ?
Because ನಾನು 50% ಇಂದ ಕೆಳಗೆ ಬರ್ತೇನೆ. If I go below 50%, I may use somewhat of
ಟ್ರೈ
information.
ಮಾಡಿ ನೋಡಿದ್ದೀರಾ? ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ರಿಸರ್ಚ್. ಹ್ಯಾವ್ ಯು ಟ್ರೈಡ್?
What, sir?
Whether you tried with other numbers?
Sir, that is below 50 you are asking?
No.
Above 50?
No. So you have selected the numbers randomly. It's my client. ನಾನು ಹೇಳ್ತಿರೋದೇನಂದ್ರೆ ನೀವು ನಂಬರ್ಸ್ ಥ್ರೆಶೋಲ್ಡ್ನ ರ್ಯಾಂಡಮ್ ಆಗಿ ಸೆಲೆಕ್ಟ್ ಮಾಡಿದ್ದೀರಾ. ವಾಟ್ ಇಸ್ ದ ಸೈಂಟಿಫಿಕ್ ವೇ ಆಫ್ ಡಿಸೈಡಿಂಗ್ ದ ಥ್ರೆಶೋಲ್ಡ್?
I have selected randomly. I have selected based on my whatever they.
No, ನೀವು ಸೆಲೆಕ್ಟ್ ಮಾಡಿ ಕೆಲವೊಂದು ನಂಬರ್ಸಿಗೆ ಮಾಡಿದ್ದೀರಾ. ಇದಕ್ಕಿಂತ ರಿಸಲ್ಟ್ ಚೆನ್ನಾಗಿರ್ಬೋದು ನೀವು ಬಿಟ್ಟಿರೋ ನಂಬರ್ಗೆ.
But I have tried with those also. But they are constant.
No, we need a scientific answer from your side, precise answer. And also, it is medical image compression. This is old method. What's new here? The method is.
That is method is new, but no one has applied for DIFF images. The only for JPG images they have tried. DIFF image is a larger size. In a larger size, no one has tried. Almost the experiment has made on DICOM image, JPG images. This is not on DIFF medical images.
Okay, so it was there for other images. You have tried for this image.
Yes.
Okay. Then you can keep changing to other
Yes,
images.
that's why my future work is that is increasing the compression ratio as well as the SSI and utilizing different techniques. I am trying to do that also.
But you have mentioned many things and what method is applied here. So you have mentioned 4 methods, right?
Yes.
Which method is applied for compression?
Maybe I have used a wavelet that is to overcome the extra compression ratio to get an extra.
On what basis?
Huffman coding lossless method.
Wavelet ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀರಾ?
No sir, wavelet is combined with the Huffman coding to get a more accuracy.
ಹೌದು ಮೇಡಮ್. On what basis wavelet and Huffman match ಆಗುತ್ತೆ ಅಂತ how do you select and what?
I have studied some papers. In that I have took a one base paper.
Okay.
So I have decided to go with that particular paper.
You not found any other matching, only these two?
Actually, actually I am working on relevant coding.
Out ಮಾಡುವಾಗ they might have considered these two. There may be better option other than this you could have considered. ಇದನ್ನು ಬಿಟ್ಟು ಬೇರೆ ಆಪ್ಷನ್ ನೀವು ನೋಡ್ರಿ.
I have not checked. When I checked,
The results may be better.
I need to compare this result with another experiment. Still it is working on. I am working on the relevant coding.
But the details about experimentation not found, right? I think it's included in paper, right? Our paper says in the right details, no?
Yes, sir.
Experimentation.
Yeah, yes, sir. It is there.
So audience, you have any questions? Sir?
What about normal images? Normal images.
JPG and other.
No, you have selected image medical images.
Medical images.
What about natural images?
It is also work for standard DIFF images also. For example, camera, one image is this for a DIP. That is also I have experimented. But I am mainly concentrating on a medical field, so I have chosen this city images.
You have mentioned data set. How many data sets you have collected?
Today, when I downloaded it from a Canadian database, it's having 100 images in the one file.
Then what about other image formats? You have other image formats also you have considered, or if
Only
why you haven't?
that's why it is having a highest size. So I have selected that one.
What about resolution of image?
It is having the highest quality and high resolution with the most storage space it required. That's why I have selected. When you compare with the JPG, PNG, it is having a more quality and high resolution.
Then you have mentioned HAAR.
What's it?
AAR. In this slide.
Hard wavelength. The DB1 itself is called as a hard wavelength.
And you haven't mentioned PSNR MSC calculation steps.
Yes, sir, it is there in this image itself.
I think you have to mention its equations also.
I can say orally, but it is there in a paper.
Before moving to experimentation.
No, we got a calculation, sir.
I think you have to mention about data set and PSNR MSC calculation steps.
Yes. It is there in a paper, but I have it here.
Paper, but you have to mention it. Okay.
Thank you.
Thanks.
Yeah, one more question.
First of all, thanks for the presentation. So you said you have downloaded the data set from Kaggle.com, right? I think for what purpose they have uploaded the Kaggle in this kind of data set?
The TIFF data set. They having all type of data set in that. PNG is there, JPG is there, TIFF, all type of images are there. All type of formats are stored there.
I think you know the purpose of Kaggle, right?
What's it?
The purpose of
Kaggle,
yeah. They will not only found the data set, but also you can find the related papers.
What?
The related papers for this data set.
Yeah, that's
have you explored the related data, related research papers, what they have done?
No, sir.
That you have to do. Otherwise, you cannot claim that whatever the data set which have been uploaded into the Kaggle did not be like they have done work on it. So after they done some
They
work,
have work, sir,
yeah,
but for this compression they didn't work. So
that's what they have done. That should be highlighted here. Okay. Thank you.
Thank you, ma'am. Now, it's paper ID 36 with paper titled A Review Paper on Silkworm Farming Automation using Artificial Intelligence, Machine Learning and Cloud-Based Solutions.
Yeah, so good evening everyone. I'm Varun. I'm a fourth year engineering student from BMS College. So our study is more of a literature review into various cloud-based, cloud computing-based solutions and AI techniques in sericulture. So brief introduction into what sericulture is. Since times immemorial, silk has been considered as a sign of royalty and auspiciousness. And silk has a very significant role in Indian culture also. So silk farming might be a small sector in agriculture, but commercially it is very huge because it employs close to 9 million people in India. So any methods aimed towards automation in this field is highly efficient. So AI in translational agriculture. So what I mean by translational agriculture is they have how researchers have inculcated AI in other fields of agriculture and how best they can improve crop yield quantitatively. So it is a well-known fact that IoT solutions and AI solutions have been incorporated into farming practices practices which have yielded in better crop quality and better yield and in terms of management of farming costs as well. So, including sensors to monitor soil health, checking for soil conditions, tracing of farm animals are some of the areas where AI and cloud computing are used. So, regarding scope of artificial intelligence in silk farming, so starting from the cultivation of mulberry plants until the weaving of silk fabric, there are multiple areas in which AI can be inculcated to increase results. So let us look at a few use cases where current research teams are working. So egg counting. So we need to understand why egg counting needs to be automated. So as you all know, silk eggs are very delicate in nature, and you cannot handle them, manhandle them or break them. There is a very high chance of wastage. So any image-based, egg counting methods would be very useful in controlling the wastage of eggs in sericulture markets. So generally, thresholding-based image segmentation methodologies are used for segmenting these eggs, and some counting algorithms are used for counting the total number of eggs.
You can straight away go to your contribution because the survey paper, right?
Yeah.
So what is your view on this total survey? Because these are the techniques already available.
Yes.
You, after going through all these techniques, your remarks and observations revert straight away.
Yes. So even though there are IoT-based, cloud-based, and AI-based solutions for sericulture, widespread adoption is missing.
You go back to the previous case. Okay. So the two deformate techniques.
Yeah.
Determination. So you are explaining about the artificial intelligence model, machine learning models, and with cloud.
Yeah. Cloud and
what actually you are trying to convey at the end?
we are trying
After
to
going through your paper, what is the takeaway for the audience?
major takeaway is how to improve the current state of the field.
Yeah, you go straight away to that. How you are going to improve?
So one thing that is lacking in AI applications in sericulture is lack of open source technology in sericulture. In terms of collaboration, researchers are lacking in providing open source data sets where the research community can come together and provide better results.
And also you have two terminologies, artificial intelligence and machine learning. What is the difference between these two as applied to your survey? What is the difference between AI methods and machine learning methods?
AI methods refers to using
because you have included both. So can you tell me which are AI methods, which are machine learning methods in your survey?
The exact boundary would be very hard to tell.
So then, I don't know, you may be having both the methods here. Which are AI methods, which are machine learning methods, and anyway, let us talk about clouds later.
Yeah.
So you discriminate between AI methods and machine learning methods as you mentioned in the title of the paper.
Yeah. So
when you talk about future scope, we are talking about only artificial intelligence.
Yes.
Where that machine learning is missed here.
This is like more of an umbrella sharing.
So means to say both artificial intelligence and machine learning are same.
Not trying to imply that, but what we are trying to say is there is a general scheme where we can improve this.
Okay, anyway, say it is good effort, but only thing is you need to be very precise. When you are conveying, your title itself is ambiguous. You started with artificial intelligence and machine learning and one more keyword, cloud. So we have not seen anything related to cloud here. You just you started with many things where it could be applied. So, but what are your remarks after going through this?
Exactly, sir. So there is a lack
you talk in terms of challenges.
Yeah.
And challenges?
Yeah, so I was coming to that. Yeah. So one thing that is missing, in modern sericulture practices is lack of communication of research work into actual real world.
No, you started with egg counting.
Yeah.
So egg counting maybe it's fine. What are the challenges involved in the existing algorithms? What is that accuracy? In terms of those, you need to speak.
Yeah, exactly.
No, we have not shown any survey, literature survey here, because it is survey paper, right? So with respect to egg count, which are the papers available in the literature, and what is that accuracy reached? What are the challenges? What could be done? Suppose if somebody goes through your paper, they must be able to understand at the end. So with respect to the subheadings like egg counting, etc. So existing literature is this. There is scope for further research. We have not seen such flow here. Okay. Anyway, so good effort. Audience, you have any other questions? So anyway, effort is fine. You need to present very methodically, and before framing the title, you go through twice. That is artificial intelligence, machine learning, image processing. Many things have been used here, but you need to have clarity.
Yes.
Right? And also, when you go with survey paper, at the end, something must be there for the people to draw the inference and conclusion. So it is not finding here. Anyway, it's good attempt. All the best. Audience, if there are no questions, I will go with the next paper. Sorry.
Some comparison you can specify.
We have discussed.
Citation is missing here, which is a survey paper. You have to give citations. This you have created also, you have collected it from somewhere else, right?
What?
You have collected it from somewhere else, this one.
Yeah, we have actually cited that in the...
You have to cite.
Actually, you have service asking that particular image, picture has been taken from somebody, right?
Yes, it was in
You
fact
have
taken.
to give citations.
And you are acknowledging that you are not going to.
No, sir.
Before
We have cited all these things.
Before references, you have to keep one table. In that table, you have to mention each survey paper and what are all the which expression is there in classifier. There you have used everything. You have to select and you have to keep everything in that. That is required in survey paper. Comparative analysis is required.
Thanks.
Thank you, sir. Now it's paper ID 45 with paper title Efficient Wavelet-Based Denoising Technique combined with features of cycle spinning and BM3D for grayscale and color images.
Yes, please.
Good evening, one and all. My name is Shilpa. Research scholar from the Department of Computer Science, Karnataka State Accounting University, and the guidance of Dr. Rajiv Masana, sir. Today I am going to present on the topic efficient wavelet-based denoising technique combined with features of cycle spinning and BM3D for grayscale and color images. So denoising is one of the major crucial step in the pre-processing when it comes to digital image processing applications. And one of the major trade-off in denoising technique is the smoothing of images. So when we talk about the denoising, we will
So efficient wavelet-based denoising, right?
Yes.
You go straight away to your contribution. Yeah, and also if you have a single page of survey, you can show, or otherwise you your contribution in terms of experimentation. You said that it is efficient wavelet. What do you mean by that efficient, and how do you go to that part and you
Okay. So here what I have done, I have in order to achieve noise removal as well as preservation, I have used two algorithms.
algorithms, BM3D and wavelet-based denoising technique.
So this is the methods already available, right? What we would like to know, what is
So
your
here what I have done is,
this is your contribution, right? So you have done experimentation.
yes,
So what is the efficient wavelet?
yes sir. So here I have
On
considered
what basis you decide that it is efficient?
So when I have combined wavelet-based denoising technique along with the BM3D, I got better results when I compared with the what experiments I have done. So here I have taken BM3D algorithm as well as in case of wavelet, I have added noise, Gaussian noise I have added to.
Which noise is added here?
Gaussian noise.
Why only that noise?
That is usually occurring noise.
No,
And
so no, you see, you are selecting that. Which are the other types of noise available?
Poisson noise, spectral noise.
Why not others? What made you to go with this particular noise only?
So since it is the basic noise which
No, what is the criteria to select? Because for your experimentation, you selected among 5 available types.
Yes.
You selected one type, right?
Yes.
What is the reason and what basis it has been selected?
So as it uses normal distribution, so the noise removal is the distribution of the noise is.
So normal distribution is used in it?
Yes, Gaussian distribution of the noise.
Okay, so what is the reason to go with those two? Why you have selected that noise?
Actually, I have done a paper previously where I have used all type of noises and different filters I have applied, and so here I thought
Yeah, you need
as
to,
I am
no,
trying with
yes, it is fine, your attempt is fine. You need to give scientific justification that why it has been selected. Because is it ad hoc or is it some random way of selecting?
spectral noise is the one which usually occurs.
ಸರಿ, ನೀವು ಇದನ್ನ ಮಾಡ್ಲಿಕ್ಕೆ ಕೊಟ್ಟಿದ್ದೀರಲ್ಲ, ಸೆಲೆಕ್ಟ್ ಮಾಡುವಾಗ ಏನು ಬೇಸಿಸ್ ಅಲ್ಲಿ ಸೆಲೆಕ್ಟ್ ಮಾಡಿದ್ರಿ?
Other methods I have tried in my previous papers, sir. Spectral noise is
But
the one which
you
occurs.
are claiming that this is your work, right? Where is that experimentation details?
Yes, sir, I did that. So here for bioorthogonal, since in the wavelets, bioorthogonal wavelets are better for image denoising. So I have taken bioorthogonal wavelets and compared.
Your statement is bioorthogonal wavelets are better for denoising.
Yes, it gives good results compared to the remaining.
So how do you justify that it is right?
Actually, bioorthogonal wavelets uses 2 scaling factors, sir. One of the major advantages in wavelet is.
Have you seen such papers in the literature?
Yes, sir.
Then why have you mentioned such papers here?
In the reference, I have.
Okay, in which year it was?
It was in 2018.
Okay, after that there may be better papers, better than that particular.
So here I have like BM3D and bioorthogonal both I have combined, sir. And I have used one more feature called cycle spinning, where we use rotation of the images, row-wise and column-wise. So that feature I have added with wavelet-based denoising and then combined the results with the BM3D filter.
Okay, show me the experimentation details.
Yes, sir. So here I have added different threshold values and.
So which are the different threshold values?
So universal threshold, minimax, phase and Shor string threshold values. So among which Shor string was given.
No, very same question with the previous presenter. We talked about threshold and how to fix the threshold. Same question for you. So how about fixing the threshold? On what basis threshold will be fixed?
Threshold value, depending upon, in case of universal threshold, it takes the variance of the noise, sir, and then the size of the image. Based on that, it is going to calculate the threshold value. And then minimax, it uses the minimax rule, where the minimum threshold value and if it is less than minimum or greater than maximum, that those values will be.
Is it right way of deciding threshold? No. My question is it right method of deciding threshold? How do
By applying different techniques, I have tried. If the result.
Fine. Okay, for the experimental results.
And these are the performance parameters I have used. Qualitative as well as
So
quantitative.
what is the PSNR?
It is peak signal to noise ratio, sir.
So
And
okay, so how this performance, what is the contribution of PSNR and what is MSE?
MSE is means per error between two images. So when we compare pixel by pixel two images, what is the, it is going to calculate.
Well, what are your observations with respect to MSE and PSNR in this experimentation?
These are the observations with respect to one of the image I have shown, sir. Here I have taken the grayscale image bar graph. So for when we compare the PSNR values, the proposed technique is giving greater PSNR values, and MSE values are less. They are reducing when compared to the previous methods, and SSIM values are almost
In the literature, very similar papers are there, right? How your paper is different? How your work is different?
So here one thing I am trying to combine the transform domain technique with the spatial domain technique BMP.
Okay, so which is the spatial domain and which is the transform domain?
Wavelet
based technique is?
Yes.
Whether it is spatial or transform
It is
domain?
transform domain.
Okay, which is the spatial domain technique?
EM3D is a spatial frequency domain technique where we use collaborative filtering, that is the linear transform is done, then linear filtering is done, and then inverse transform will be done.
Okay. Transform domain you selected wavelet.
Yes.
Why not others? Even DCT, DFT, there are many things. What made you to go with wavelet?
Sir, in case of wavelets, it considers both time as well as frequency. We can we can calculate the frequency at different levels by using scaling and shifting properties of the wavelet.
What are your observations if you replace wavelet with some other technique of transform domain? If you replace wavelet by some other technique from transform domain, what will be the expected results?
Actually, these wavelets are giving better results, sir. I have compared, but I have not shown in my papers. I have tried different wavelets also and FFT also.
What is the literature survey? What are your remarks on literature survey with respect to only wavelets? Because you are going with hybridization, right? One spatial domain, one transform domain. So, what is the result of only wavelets, transform domain? And then you hybridization ಮಾಡಿದಿರಲ್ಲ, ಬರೀ if you go with only one technique, what are the results?
So in the wavelet domain, what happens? It is going to perform decomposition. So it decomposes the image into
No. So I'm not talking about wavelet. There are other methods also in transform domain.
Yes.
So what is the behavior of this particular experiment?
It preserves the edges, which are very important for further processing of the images, like object detection or like feature. Edges are one of the important features in the images, so it proves better in preserving the edges.
Okay. Right. What is the SSIM?
It is structural similarity index measure.
Right.
So here it is called as a qualitative measure. So those two are quantitative measures which considers the image pixel by pixel to calculate the difference between the images. Here it is going to consider the group of pixels. Those group of pixels will be compared with the other set of pixels of the other image. So windows of X image and Y image of size n cross n will be compared with these.
Okay. So next. So this is the comparison. Okay. What are your closing remarks with respect to this particular slide?
Overall, the combined method or the hybrid method is giving better results with respect to both qualitative and quantitative measures.
Okay, hybrid method, one is from transform domain, one is from spatial domain. This hybrid method is giving better results. Okay.
And with respect to color images also, it is giving good results. And in color, the images, instead of applying cytoscaling feature, and use color spacer where the image is being transformed to PCA, there is denoising is performed. So which improves the results.
Sir. Audience, you have any other questions? Anyway, if there are no questions, thank you very much. So presentation is fine, but you need to focus on minute details. So because if you are selecting a particular method or methodologies, you need to have scientific justification, or otherwise it is ad hoc. Correct. So right. Thank you.
Some details you have to mention. If you just mention the
You need to have mathematical justification basis. Anything you do, you need to have basis. Scientific basis must be there, which is lacking here. In future, you will improve. All the best. Thank you. If there are no questions from audience, so we'll go to the next presentation. Thank you.
Thank you, ma'am. Now, it's paper ID 49 with the paper title Surface Water Quality Analysis using IoT.
Good evening, everyone. I'm MIJAR. I'm from Amrita School of Arts and Science, Mysuru, and my paper title is Surface Water Quality Analysis using IoT. Introduction. The impact of water on any living thing is beyond our description. The rapid increase of the world population to water management becomes an important issue, especially in industrial, agriculture, and other sectors.
So straight away go to your contribution. So this we are aware that this is one of the sustainable development goals.
Most of the authors has done their work. Most of them are accurate. Most of them are very well done their work. But what is my contribution in this is we are categorizing along with the measuring the water physical parameters. We are also categorizing stuff, whether it's suitable for agriculture or whether it's suitable for aquaculture or whether it's suitable for drinking based on its pH.
So based on the pH value, your paper gives suitability where it is suitable, right?
Yes, sir. Mainly water reservoirs, not it's not like a water purifier or something. Like surface water reservoir or any water body like ponds, lakes.
Okay, anyway, you go straight away to your contribution. So you start with related work. 2014, 2018, 2014. So last 8 years, do you feel that nothing has been done? There may be some other techniques which have been done in 2019, 2020. You are not aware. Because any survey if you do, it must be up to the present day. Or otherwise, what is the guarantee that whatever you are intended to do might have been done somebody else already? So this is 2014. Next it is 2018. 4 years. You know, No. You need to have the concept of literature survey. You need to start from earlier papers, but present paper it will give the clarity to what extent the work has been done with respect to that particular domain. Or otherwise, after 2018, there will be a good number of papers which are contributing to it. Can you claim that no papers after 2018 related to this? You whenever you come with the literature survey, it must be exhaustive, it must be comprehensive. So when you say that this is literature survey, it must be up to date, as on date. Right? Okay, next.
Objective of my research paper is to develop a small water quality monitoring system using IoT platform for water reservoirs.
So you are developing smart water quality monitoring system. What do you mean by smart?
Using IoT devices like sensors.
No, smart.
This is my
Smart means what? So do you feel that question is invalid?
No, I was thinking how to explain it. What is this by using by using new technologies?
Okay, so usually next it your proposed system is next it. Categorizing the water pH value. What is pH value?
Hydrogen ion in the water.
Okay, so how do you categorize?
Sir, if the water pH level lies between 7.5 to 6.5, we categorize as clean. If the water pH value lies between 6.5 to 5.5, then we categorize it as agriculture. If the pH value lies between 7.5 to 9.5,
Okay, so based on this you are deciding, your paper is deciding about suitability, where it is suitable. So based on pH value. Then it's already there. What is that experimentation and scientific methods involved here? So pH value ತಗೊಂಡು based on the pH value if you are classifying, it's fine. Even ಮಾಡ್ತಾ ಇದ್ದೀರಿ ಇದರಲ್ಲಿ. What is the contribution of concept called AIET here? What for it AIET is used? So now we are incorporating cloud also. What for cloud is included here? Cloud act ಬೇಕಾಗಿ. So ನಾನು ಕೇಳ್ತಾ ಇದ್ದೀನಿ No, you forget about cloud. What is the concept? ನೀವು ಇದನ್ನು ಏನು ಹೇಳಿ ಕೊಟ್ಟಿದ್ದೀರಿ ಅದು make it one ಮಾತ್ರ. See, what we would like to know, what is your contribution here? These things are already there, no? ನೀವೇನ್ ಮಾಡಿದ್ದೀರಾ ಅಂತ ಹೇಳಿ, ಸ್ವಲ್ಪ ಕಡಿಮೆ ಇತ್ತು ಮೊಬೈಲ್ ಆಗಿ. Let us see the next slide, maybe there. Results ಹೋಗಿದ್ರಲ್ಲ, what is the observation with respect to this slide? Yeah, in this slide gives about pH level variations. Now what is what is fine. What is the difference and where you are connecting this?
Suppose I have a glass of water, how will your system will identify its quality? Any features? Suppose I have a glass of water, how will your system identify its quality? Your IoT system will identify the quality of that water. Smart water quality analysis, right? Any other features to identify the quality of surface water? There is no other features. Already, water quality analysis using machine learning is available. Machine learning. Some features we can identify from that. In future we can try. What are the features to identify the quality of water? And what is the purpose of that cloud-based system in your cloud-based system? Where is the cloud-based system? What is the main purpose? Why are you using that cloud-based system in your work? Okay, how many sensors you are using? So only these features you are considering for your work.
Audience, you have any other questions? If there are no questions, thank you. So, the selection of problem is fine, but presentation leads improvement. Okay.
I thank all the presentees for the wonderful presentation. Now, I request Dr. Vinay Kumar X to give the mementos to Dr. Swamiji as a token of gratitude.
Are they right?
So introduction, in India, agriculture is the main source. So it is crops, seeds, resilience and circumstances. These circumstances are caused mainly by the significant nutrition such as nitrogen, potassium and phosphorus. Here we are mainly brownish. Divided into two phases, training phase and the testing phase. In the training phase, we are taking some samples of the image, field images that are applied to the pre-processing, segmentation, picture extraction, then to the classifier, SVM training and all. So after processing these all things, it is in the SVM training, it is training to the system, giving the training to the system that if the field is healthy, what is its characteristics, and if it is having a nitrogen deficiency, what are its characteristics, that information is stored in the knowledge base. Then whenever we are, and then in the next second phase, this knowledge base is used by the testing phase. So in the testing phase, the suddenly or any unknown input static field image is taken. Then that static field image is transferred. Static field image is during the testing static field is reading and then transferred to the pre-processing. So in pre-processing, it is the process of noise removal and recycling is done using the medium filter. After performing the pre-processing, that is removing the noise and the recycling it is the image is reversed and that is unwanted region is removed. Then it is transferred. Unwanted region means in the field we are taking the nitrogen deficiency image as a more important one. That is transferred to the suspected, it has taken as suspected region and then it is transferred for the hierarchical color segmentation process. In the hierarchical color segmentation process, as it is of a huge image, big image, it is not possible to do at once. So here that image is divided into blocks. Okay, that blocks are transferred for the color segmentation. So in the color segmentation, here we are using the table threshold value, nitrogen threshold value. If the nitrogen threshold value in a green plane 34 to 67 and in a blue plane 52 to 54. So if the values are in this region, then that field or that area is considered as a nitrogen deficient region. Then after extracting the nitrogen affected region and dividing the nitrogen deficient region and the healthy region, it is not sufficient that only on that we can categorize. So that for that purpose we are going for the feature extraction. So in the feature extraction, quantitative assessment of one or more functions are what are known as the features. Only one function is not enough for the extraction categorization. So here we are using the variable flow and movement. So in order to analyze the picture as a texture, we need statistics of the second order that are based on the CSE. Here the features used for the feature extraction are energy, entropy and correlation. After feature extraction, we are going for the SVM classifier. SVM classifier is a well-known superposition classification and a regression technique. The fundamental goal of the SVM is to create the best judgment boundaries for categorizing the mean kappa points. So why we are going for the SVM classifier? We want the most straightforward data categorizing decision boundary. For that purpose, we are going for the SVM classifier. SVM classifier is using the knowledge base to extract the characteristics of how the healthy field should be, how the unhealthy or nitrogen deficient field should be. So after extracting this knowledge, it is going to classify the healthy and unhealthy.
Madam, can you focus on your contribution here? You focus on your contribution. You are talking about the SVM classifier, yield estimation, etc. What is your contribution and what challenges have been addressed here? What is the outcome?
Yes, unhealthy of a nitrogen deficient part. So here unhealthy region characteristics of the deficiencies in the healthy. So and one more is for another performance analysis. Here we are using the confusion matrix. So which is used to calculate or find out the accuracy of
Thank you, madam. Thank you. So you were eagerly waiting to complete that. Because that's why you -1, you made it -1, since -1, fine. But 6th is not there.
Now, there is a cultural extravaganza at Divine Auditorium.